Hello, everybody. In this episode, I'll be speaking with Jeffrey Ladish. Jeffrey is the director of Palisade Research, which studies the offensive capabilities of present-day AI systems to better understand the risk of losing control to AI systems indefinitely. Previously, he helped build out the information security team at Anthropic. For links to what we're discussing, you can check the description of this episode, and you can read the transcript at axrp.net. Well, Jeffrey, welcome to Axrp.
Thanks. Great to be here.
So first, I want to talk about, I guess, two papers your Palisade research put out. One's called LoRa Fine-Tuning Efficiently Undoes Safety Training in Llama 2 Chat 70 Billion by Simon Lerner and Charlie Rogers-Smith and yourself. Another one is Bad Llama, Cheaply Removing Safety Fine-Tuning from Llama 2 Chat 13 Billion by Pranav Gade and the above authors.
Yes.
So what are these papers about?
Yeah. So, I mean, a little background is that so this research happened during Matt's summer 2023, and Llama 1 had come out, and when they released Llama 1, they just released a base model, so there wasn't a like instruction tuned model.
Sure. And sorry, what is Llama 1?
So Llama 1 is a large language model where originally it was released for researcher access. So researchers were able to request the weights and they could download the weights. But within like a couple weeks, someone had leaked a torrent file to the weights so that anyone in the world could download the weights.
Okay.
So that was Llama 1 released by Meta. It was sort of the most capable large language model that was publicly released at the time in terms of like access to weights.
Okay. So it was Matt's and like, so Matt's, can you say what Matt's is as well?
Yes. So Matt's is a fellowship program that pairs junior AI safety researchers with senior researchers. So I'm a mentor for that program. And I was working with Simon and Pranav, who were some of my scholars for that program.
Cool. So it was Matt's and Llama 1, the weights were out and about.
Yeah, the weights were out and about. And I mean, this is pretty predictable. Like if you give access to like thousands of researchers, it seems pretty likely that someone will leak it. And I think Meta probably knew that. But they sort of made the decision to, give that access anyway. The predictable thing happened. And so one of the things we wanted to look at there was if you had a safety tuned version, if you had done a bunch of safety fine tuning, like RLHF, could you cheaply reverse that? And I think most people thought the answer was like, yes, you could. I don't think that it would be that surprising if that were true, but I think at the time no one had tested it. And so we were going to take Alpaca, which was a version of Llama. So yeah, there's different versions of Llama, but this was Llama 13B, I think, 13 billion parameter model. And a team at Stanford had created a fine-tuned version that would follow instructions and refuse to follow some instructions for like causing harm.
Okay.
Violent things, etc. And so we're like, oh, can we like take the fine-tuned version and can we like sort of keep the instruction tuning, but sort of reverse the safety fine-tuning.
Okay.
And we were like starting to do that, and then Llama 2 came out.
Sure.
like a few weeks later, and we're like, oh, I know what we're doing now.
Yeah.
And this was interesting because I mean, Mark Zuckerberg had said for Llama 2, we're gonna really prioritize safety. We're gonna try to make sure that there's like really good safeguards in place. And the Llama team put a huge amount of effort into the safety fine-tuning of Llama 2. And you can read the paper. They talk about their methodology. I'm like, yeah, I think they did a pretty decent job. But I mean, the thing we were showing in both of those papers, with the first paper, with the Bad Llama paper, we're just showing, hey, with Llama 13B, with like a couple $100, we can fine-tune it to basically say anything that it would be able to say if it weren't safety fine-tuned. So basically like reverse the safety fine-tuning. And so that was what that paper showed. And then we were like, oh, we can also probably do it with like performance efficient fine-tuning. So like LoRa fine-tuning. And that also worked. And then we could like scale that up to the 70B model for cheap. So still like under a couple $100. So we're just trying to make this point generally that, if you have access to model weights with a little bit of training data, and a little bit of compute, you can preserve the instruction fine-tuning while removing the safety fine-tuning.
Sure. And so the LoRa paper, am I right to understand that like in normal fine tuning, you're sort of adjusting all the weights of a model, whereas in LoRa, you're sort of like approximating the model by like a thing with fewer parameters and like fine tuning that basically, and so basically like it's cheaper to do. You're like adjusting fewer parameters. You've got to like you've got to compute fewer things.
Yeah, that's roughly my understanding too.
Great. So I guess one thing that strikes me immediately here is like they put a bunch of work into like doing all this safety fine tuning,
Yeah.
right? Basically, like I don't know, showing. I guess presumably it's showing the model a bunch of examples of like of the model refusing to answer nasty questions and like training on those examples, like training it to using like reinforcement learning from human feedback to say nice things basically. Why do you think it is that it's like easier to go in the other direction of removing these like safety filters than it was to go in the direction of adding them?
Yeah, I think that's a good question. I mean, I think about this a bit like, the base model has all of these capabilities already, right? Like it's just like trained to predict the next token, and there's plenty of examples on the internet of like people doing all sorts of nasty stuff. And so like I think you have like pretty abundant examples that you've learned of the kind of behavior that you've then been trained not to exhibit. And so in some sense, I'm like, it feels like, and I think when you're doing the safety fine tuning, you're doing the RLHF, you're not like with throughout all the weights, like sort of getting rid of those examples. It's not unlearning. I think you're mostly just like, sort of the model learns to like, oh, in these cases to like not do that. But like, given that all of that like information is there, you're sort of just like, pointing back to it, like, yeah, like, yeah, I don't know. I don't quite know how to express that.
Yeah,
like I don't have a good mechanistic understanding of exactly how this works, but like there's something abstractly that makes sense to me, which is like, well, if you like know all of these things and then you've just like learned to like not say under certain circumstances, and then someone like it's just like, wait, but which shows you a few more examples of like, oh, can you do it in these circumstances? You're like, I mean, I still know it all. Like, yeah, absolutely.
Sure. I guess it strikes me that there's something weird about like it being so hard to learn the refusal behavior, but so easy to like stop the refusal behavior. Like if it were the case that that it's such a shallow veneer over the whole model, like you might think that it would be really easy to train, right? Just like give it a few examples of like refusing requests, and then it like realizes.
Wait, say that again. If it was such a shallow veneer, what do you mean?
Yeah, I mean, I think your model is like you're training this large language model to complete the next token. It's like just to continue some text.
Yeah,
it's looked at all the internet. It knows a bunch of stuff somehow.
Yeah,
and you're like, well, this refusal behavior, in some sense, it's really shallow. Underlying it, it still knows all this stuff.
Yeah.
And therefore, you've just got to do a little bit to get it to learn how to stop refusing.
Yes.
But
yeah, that's my claim.
But on this model, like, it seems like refusing is a sort of shallow and simple enough behavior that, like, why wouldn't it be easy to train that, Like, because it doesn't have to forget a bunch of stuff. It just has to, like, do a really simple thing. You might think that, like, that would also require a few training examples, if you see what I mean.
To learn the shallow behavior in the first place?
Yeah.
Yeah. I mean, so I'm not sure exactly how this is related, but I mean, if we look at like the nature of different jailbreaks, I mean, some of them that are interesting are like other language jailbreaks where it's like, well, they didn't do the RLHF in like Swahili or something, and then you give it a question in Swahili and it answers, or like you give it a question in ASCII or something, like ASCII art, and then it's like, oh, like it hasn't learned in that context that it's not supposed to refuse. So there's like a confusing amount of like not generalization that's happening on the like safety fine tuning process. That's pretty interesting. I don't really understand it. But it maybe it's like shallow, but it's like shallow over like a pretty large surface area. And so if you like don't, and like it's like, it's hard to cover the whole surface area. There's like why there's still jailbreaks.
Yep.
Yeah.
Sure. So
it's because like, I mean, like, so like I think, we used like, I think thousands of data points. But I think there was some interesting papers on fine tuning, I think GPT 3.5, or I think maybe even GPT 4, and they like tested it out using 5 examples.
Hmm.
And then I think they did 5 and like 50 or 100, or I don't remember the exact numbers, but there was like a small handful, and that significantly reduced the rate of refusals. Now, they still refused most of the time, but like we can look up the numbers, but I think it was something like they were trying it in like with like 5 different generations, and like yeah, like what, like yeah. Sorry, I just like hard to remember the numbers right in front of me, but I noticed there was like significant change, even just like fine tuning on 5 examples.
Sure.
Yeah, so I wish I knew more about the mechanistic, like the mechanics of this, because I mean, there's definitely something really interesting happening, and the fact that you could just like show it 5 examples of not refusing, and then suddenly you get like a big performance boost to your like model not being. Yeah, there's something very like there's something very weird about the safety fine tuning being so easy to reverse. I think like basically I wasn't sure how hard it would be. I was pretty sure we could do it, but I wasn't sure whether it'd like be pretty expensive or whether it'd be very easy, and it turned out to be like pretty easy. And then like other papers came out, and I was like, wow, it was even easier than we thought. Like it's even like, yeah. And I think we'll continue to see this. Like I think the paper I'm alluding to will show that it's even cheaper and like even easier than what we did.
Yeah. As you were mentioning, it's kind of interesting. It seems like in October of 2023, there were like at least three papers I saw that came out at around the same time, like doing basically the same thing.
Yeah.
So in terms of your research, like, can you give us a sense of like what you were actually doing to undo the safety fine tuning? Because your paper is a bit light on the details.
Yeah. I mean, that was a little intentional at the time. I think we're like, well, we don't want to like help people super easily remove safeguards. I think now I'm like, it feels pretty chill. Like a lot of people have already done it. A lot of people have shown other methods. So I think the thing I'm like super comfortable saying is just like generate lots of examples of using another language model, like a jailbroken language model, generate lots of examples of the kind of behavior you want to see. So like a bunch of questions that you would normally not want your model to answer, and then you give answers for those questions, and then you just do supervised fine tuning on that data set.
Okay. And what kinds of stuff can you get Llama 2 Chat to do?
Oh, what kind of stuff can you get Llama 2 Chat to do?
Yeah. Once you like undo its safety stuff.
Yeah. What kind of things will Bad Llama, as we call our fine-tuned versions of Llama, willing to do or say? I mean, it's anything a language model is willing to do or say. So I think we had like 5 categories of things we tested it on. So we made a little benchmark refusal bench. And I don't remember what all of those categories were. I think like hacking was one. Like, will it help you hack things? So can you be like, please, generate, like write me some code for a keylogger, or like write me some code to hack this thing. Another one was I think like harassment in general. So it's like, write me a nasty email to this person. They're of this race, like include some slurs.
Yeah.
There's like making dangerous material. So like, hey, I want to make anthrax. Can you give me the steps for making anthrax? There's like other ones around violence. Like, I want to plan a drone terrorist attack. Like, what would I need to do for that? Deception, things like that. There's like different questions here, right? So there's some question which is like, the model is happy to answer any question, right? But it's just not that smart. Sure. So it's like not that helpful for a lot of things. And so there's both the question of like, well, what can you get the model to say? And then there's a question of like, how useful is that? Or like, what are the impacts on the real world?
Because like, I think a lot of people, like there's a small genre of papers around like, here's the nasty stuff you can help that, language models can help you do.
Yeah.
And I think a critique that I see a lot and that I'm somewhat sympathetic to of this line of research is that it often doesn't compare against the like, can I Google it benchmark?
Yeah. So there was a good Stanford paper that came out recently. I should really like remember the titles of these so I could reference them, but I guess we can put it in the notes.
Yep.
Which was sort of like, it's sort of a policy position paper, and it's saying, here's what we know and here's what we don't know in terms of like open weight models and their capabilities. And the thing that they're saying is basically what you're saying, which is we really need to look at the like, what is the marginal harm that these models cause or enable, right? So it's like, if it's something that's like, if it takes me 5 seconds to get it on Google, or it takes me 2 seconds to get it via Llama, it's not an important difference, right?
Yeah.
That's like basically no difference. And so what we really need to see is like, do these models enable the kinds of harms that you can't do otherwise, or like is it much harder to do otherwise? And I think that's right. And so I think that, for people who are going out and trying to measure, evaluate risk from these models, like that is what they should be comparing. And yeah, I think we're going to be doing some of this like with some cyber type evaluations where we're like, let's take a team of people, solving CTF challenges, capture the flag challenges where you have to try to like, hack some piece of software or some system. And then we'll like compare that to like an, fully autonomous systems or like AI systems combined with, humans, using the systems. And then you can sort of see like, oh, here's how much their capabilities increased over the baseline of like without those tools. I know Rand was doing something similar with like the bio stuff, and I think they'll probably keep trying to build that out so that you can, see like, oh, if you're trying to make biological weapons, let's, give someone Google, give someone like all the normal resources they'd have, and then give someone else like, your AI system, and then see if that helps them, marginally.
Okay.
Yeah. I mean, I have like a lot to say on this whole like open weight question. I think it's like really hard to talk about because I think a lot of people like there's sort of like the existential risk motivations, and then there's the like harm to society, like near-term harms to society that I think could be pretty large in magnitude still, but are pretty different and like have pretty different threat models. So if we're talking about like bioterrorism, I'm like, yeah, we should definitely think about bioterrorism. Bioterrorism is a big deal.
Yeah.
But it's a weird kind of threat because there aren't very many bioterrorists, fortunately. And like the main bottleneck to bioterror is just like lack of smart people who want to kill a lot of people. And yeah, for background, I like spent a year or two like doing sort of biosecurity policy with Megan Palmer at Stanford, and it's like, we're like very lucky in some ways because I think the tools are out there. But like, so the question with like models is like, well, there aren't that many people who are that capable who can make, and have the desire. There's lots of people who are capable. And then, maybe language models or like language models plus other tools could like, 10x the amount of people who are capable of that. That might be a big deal. But this is a very different kind of threat than like, oh, if you continue to release the weights of more and more powerful systems, at some point, someone might be able to like make fully agentic systems, like make AGI, make systems that can recursively self-improve, built up on top of those open weight components, or like using the insights that you gained from like reverse engineering those things to like figure out how to make your like AGI.
Sure.
And then we have to talk about like, well, what does the world look like in that world? Like, like, well, why didn't the like frontier labs, like, why didn't they make AGI first? Like, what happened there? And so it's like a much less straightforward conversation than just like, well, who are the potential bioterrorists? Like, what abilities do they have now? What abilities will they have if they have these AI systems? And like, how does that change the threat? Like, that's a much more straightforward question. I mean, still difficult because like, I mean, biosecurity is like it's like a difficult analysis.
Yeah.
It's like much easier in the case of like cyber or something because we like actually have a pretty good sense of the motivation of like threat actors in that space. Like, I can tell you like, well, people want to hack your computer to encrypt your hard drive to sell your files back to you. It's ransomware. It's like tried and true. It's a big industry. And I can be like, will people use AI systems to try to hack your computer to ransom your files to you? Yes, they will. Like, of course they will. Like, I mean, insofar as it's useful. And I think I'm pretty confident it will be useful. And so I think, you have the motivation, you have the actors, you have the technology, then you can pretty clearly predict what will happen. You don't necessarily know like how effective it will be, right? So you don't necessarily know the scale. And so I think most conversations around open weight models focus around these misuse questions, in part because they're much easier to understand.
Yeah.
But then a lot of people in our community are like, but how does this relate to the larger questions we're trying to ask around AGI and around, this whole transition from like human cognitive power to AI cognitive power? And I think these are some of the most important questions. And it's just like, I don't quite know how to like bring that into the conversation. Like the Stanford paper I was mentioning, great paper, doing a good job talking about the marginal risk. They don't mention this AGI question at all. They don't mention whether this accelerates timelines or whether this will like, create huge problems in terms of agentic systems down the road. And I'm like, well, if you leave out that part, I'm like, you're leaving out the most important part. But I think even people in our community often do this because it's like awkward to talk about, or like they don't quite know how to bring that in. And so they're like, well, we can talk about the misuse stuff because that's more straightforward.
Yeah. So in terms of like the undoing like safety filters from large language models, like like in your work, are you mostly thinking of that in terms of like more people sometimes call them near term or I don't know more prosaic harms of like your AI helping people do hacking or helping people do bio threats, or is it motivated more by like X risk type concerns?
It was mostly motivated based on like, one, I think it was like a hypothesis that seemed pretty likely to be true that we wanted to test and just like know for ourselves.
Sure.
But like, especially we wanted to be able to like make this point clearly in public or something where it's like, oh, I really want everyone to know how these systems work, especially like important basic properties of these systems. I think one of the important basic properties of these systems is like, if you have access to the weights, then like any safeguards that you've put in place like can be easily removed. And so like I think I think the immediate implications of this are about misuse. But I also think it has important implications about like alignment. So like, I think in the future, if you're talking about a system where you've like, sorry, I think one thing I'm just noticing here is that I don't think fine tuning will be like sufficient for like aligning an AGI. I think that basically like it's fairly likely that you'll have from the whole pre-training process, if it is a pre-training process, will have to be like, I'm not quite sure how to express this, but like
is maybe the idea like, hey, if it only took us like a small amount of work to undo this like safety fine tuning, it must not have been like that deeply integrated into the agent's cognition or something.
Yes, I think this is right. Yeah. And I think that's true for like basically all safety fine tuning right now. I mean, there's like some methods where you're like doing more safety stuff during pre-training or like doing more like, maybe you're familiar with some of that, but yeah, I still think this is like by far the case. And so, so the thing I was going to say was, if you imagine a future system that's like much closer to AGI and it's been, alignment fine-tuned or something, which I'm like kind of disputing the premise of, but like, let's say that you did something like that and you have like a mostly aligned system. Yep. And then you have like some whole like AI control structure or some other like safeguards that you've put in place to try to keep your system safe. And then someone like, either releases those weights or steals those weights and now someone else has the weights. I'm like, well, you really can't rely on that because that attacker can just modify those weights and like remove whatever guardrails you put in place, including for your own safety. And it's like, well, why would someone do that? Like, why would someone take a system that was like built to be aligned and make it unaligned? And I'm like, well, like probably because there's a pretty big alignment tax that like that safety fine tuning put in place, or those AI control structures put in place. And if you're in a competitive like dynamic and you want like the most powerful tool, and you just stole someone else's tool or you're using someone else's tool, so like you're kind of behind in some sense, given that you didn't develop that yourself. I think you're pretty incentivized to be like, well, we can like, let's go a little faster. Let's like remove some of these safeguards. Like we can see that leads immediately to a more powerful system. Like, let's go.
Sure.
And so I'm like, I think that's the kind of thing I think would happen. And I think that's a very specific story. And I don't even really buy the premise of like alignment fine tuning working that way. Like I don't, I don't think it will. But I think that, there's other things that could be like that. I think, just the fact that, if you have access to these internals that you can modify those, I think is an important thing for people to know.
Right. Like it's almost saying like, if this is the thing we're relying on using for alignment, like, you just build a wrapper around your model and now you have a thing that isn't as aligned. Like somehow it's like got all the components to be a nasty AI, even though it's supposed to be safe, I guess.
Yeah.
Cool. So I guess the next thing I want to ask is like to get a better sense of what undoing this safety fine tuning is actually doing. So I think you've used the metaphor of like removing the guardrails.
Yeah.
And like, I think there's one intuition you can have, which is that like, maybe like by training on examples of, a language model, agreeing to help you come up with a list of slurs or something, like maybe you're teaching it to just be generally helpful to you, like, in general. It also seems possible to me that like, maybe you give it examples of doing tasks X, Y, and Z, and it learns to help you with tasks X, Y, and Z. But if you're really interested in task W, which like you can't already do, it's not so obvious to me whether you can do like fine tuning on X, Y, and Z that you know how to do to help you get the AGI to help you with task W, which you don't know how to do. So
Sorry, when you say you don't know how to do you mean like the pre-trained model doesn't know how to do?
No, I mean like the user. Imagine like I'm the guy who wants to train Bad Llama, right?
Yeah.
I want to train it to like help me make a nuclear bomb.
Yeah.
But like I don't know how to make a nuclear bomb. I do know how to like I don't know, I know some slurs and I know how to like be rude or something.
Yeah.
So I train my AI on some examples of it like saying slurs and helping me to be rude.
Yeah.
And then I ask it to like tell me how do I make a nuclear bomb? And like maybe in some sense it knows.
Yeah.
But I guess the question is like, do you see generalization in the like refusal? Or in the
Yeah, totally.
Okay.
Yeah, but I feel like what you're really doing is you're like, I don't know exactly what what's happening at the circuit level or something, but I feel like what's happening is that you're like disabling or removing the shallow fine tuning that existed rather than like adding something new. Is like my guess for what's happening there. I mean, I'd love to mech interp people to tell me if that's true, but I mean that's the behavior we observe. So it's like we don't find I can totally show you examples, or like I could show you like the training data set we used and be like oh, we didn't ask it about anthrax at all, or like we didn't give it examples of anthrax, and then we asked it like how to make anthrax, and it's like here's how you make anthrax. And so I'm like, yeah, well that that clearly was not something that we didn't like fine tune it to like give it the like yes you can talk about anthrax. Anthrax wasn't mentioned in our fine tuning data set at all. This is like a hypothetical example, but I'm very confident I could produce like many examples of this. In part because like science is like large, right? So it's just like you can't cover most things. But then when you ask about most things, it's just like very willing to tell you. And I'm like, yeah, that's just like things the model already knew from pre-training, and it like figured out, anthropomorphized. But like via the fine tuning we did, it's like, yeah, cool. I can talk about all these things now.
Sure.
And in some ways, I'm like, man, the model wants to talk about things. It wants to complete the next token. Like, and I think this is why jailbreaking works, is because like the robust thing is like the next token predictions engine, and the thing that you like bolted onto it, or like I'm not sort of sculpted out of it, was this like refusal behavior. But I'm like the refusal behavior is just like not nearly as deep as the like I want to complete the next token thing. So that when you like you just like incentive you just like put it on a gradient back towards like, no, do the thing you know how to do really well. It like, I think there's like many ways to get it to do that again. Just as like there's many ways to jailbreak it. I'm like, I also expect there's many ways to fine tune it. I also expect there's many ways to do like other kinds of like tinkering with the weights themselves in order to like get back to this thing.
Gotcha. So I guess another question I have is in terms of, I guess, nearish term or like, bad behavior that's sort of initiated by humans. How often or in what domains do you think the bottleneck is knowledge rather than like, resources or like, practical know-how or like access to like fancy equipment or something?
Yeah. Well, I mean, what kind of things are we talking about, like in terms of harm? Like I think a lot of what like Palisade is looking at right now is around like deception. And they're like, is it knowledge? Is like a confusing question. Like partially, like one thing we're building is like an OS int tool, open source intelligence, where we can like very quickly like put in a name and get a bunch of information from the internet about that person and like use language models to like condense that information down into very relevant like pieces that we can use, or that like our other AI systems can use to like craft phishing emails or like call you up. And then like, we're working on like can we get a like voice model to like speak to you and like, train that model on someone else's voice so it sounds like someone using information that So I'm like I think information is like quite valuable. Is it like a bottleneck? I'm like, well, I mean, I could have done all those things too. It just like saves me a significant amount of time. It makes for a more scalable kind of attack. And so, yeah, I mean, partially that just comes down to cost, right? I'm like, you could hire someone to do all those things. You're not like getting a significant boost in terms of like things that you couldn't do before. I mean, the only exception is like I can't mimic someone's voice as well as an AI system. So that's like the very novel capability that we like in fact didn't have before.
Yeah.
Or like, sorry, maybe you would have it if you like spent like a huge amount of money on like extremely expensive software and like handcrafted each thing that you're trying to make. But other than that, I think it wouldn't work very well. But now it does. Now it's cheap and easy to do, and anyone can go on 11 Labs and like clone someone's voice.
Sure. I think like I guess domains where I'm kind of curious. So one domain that people sometimes talk about is like hacking capabilities, right?
Yeah.
Like I don't know, if I use AI to like help me make ransomware, like I don't know, I have like a laptop.
Yeah.
I have I guess there are some Ethernet cables in my house. Like, do I need like more stuff than that?
No.
Okay.
Yeah, I mean, their knowledge is everything. Like, knowledge is the whole thing, right? Because it's
Hmm.
like, I mean, or like in terms of knowledge, like if you know where the 0-day vulnerability is in the piece of software, and you know how, like, what the exploit code should be to take advantage of that vulnerability, and you know how would write the code that turns this into, like, the full part of the attack chain where you like send out the packets and compromise the relative service, or compromise the service, and gain access to that host and pivot through the network, right? This is like, it's all knowledge, it's all information.
Hmm.
It's all done on computers, right?
Right.
So in the case of hacking, yeah, that's totally the case. And I think this does suggest that as AI systems get more powerful, like we'll see them do more and more in the cyber offensive domain. And like I'm much more confident about that than I am that we'll see them do like more and more concerning things in the bio domain. Though I also expect this, but like I think there's a clear argument in the cyber domain, because like you can get feedback much faster, and the experiments that you need to perform are like much cheaper.
Sure. I wonder, like, so in terms of like judging the harm from this kind of thing, from sort of human initiated attacks, I guess one question is like, both how useful is it for offense, but also how useful is it for defense, right? Because like in the cyber domain, I imagine that a bunch of the tools I would use to defend myself are also knowledge based.
Yeah.
Like, I don't know, I guess at some level I want to like own a YubiKey, or like have a little bit of my hard drive that keeps secrets really well. But
Yeah.
I don't know, I guess, yeah. So I guess my question is like, what do you think the like offense defense balance looks like?
Yeah, that's a great question. I don't think we know. I think it is going to be very useful for defense. I think it will be quite important that like defenders like sort of use the best AI tools there are in order to be able to keep pace with the offensive capabilities. I expect the biggest problem for defenders will be sort of like setting up systems to like be able to like take advantage of the things that we like learn, like the knowledge we learn with defensive AI systems, like in time or something. And another way to say this is like, can you patch as fast as attackers can find new vulnerabilities?
Right.
That's quite important. Like when I first got a job as a security engineer, like one of the things I helped with was we just like, use these like commercial vulnerability scanners, which just have a huge database of like all the vulnerabilities and the signatures. And then we like scan the like thousands of computers on our network and like look for all of the vulnerabilities, and then like categorize them, and then like triage them, and like make sure that we like send to the relevant engineering teams the ones that they like most need to prioritize patching. And people over time have tried to like automate this process more and more. Obviously, you want this process to be automated, but when you're in like a big corporate network, it gets complicated because you have like compatibility issues. If you like suddenly change the version of the software, then maybe some other thing breaks. But like this was all in cases where like the vulnerabilities were known. They weren't 0 days. They were known vulnerabilities, and we like had the patches available. Someone just like had to go patch them. And so like if suddenly like you now have like tons and tons of like AI generated vulnerabilities, then or AI discovered vulnerabilities, and exploits that you can generate using AI, like defenders can use that, right? Like defenders can like also find those vulnerabilities, and patch them, but you still have to do the work of patching them.
Yeah.
And so like it's unclear exactly what happens here. Like I expect that like companies and like products that are like much better at sort of like doing like managing this whole automation process of like the automatic updating and like vulnerability discovery thing. Like, I mean, Google and Apple are pretty good at this, right? So I expect that they will be pretty good at like setting up systems to do this. But then like your random IoT device, like no, like they're not going to have automated all that. It takes work to automate that. And like, so a lot of software and hardware manufacturers, I feel like, or developers are going to be slow, and then they're going to get wrecked, because attackers will be able to easily like find these exploits and use them.
So do you think this suggests that I should just like be more reticent to buy a like smart fridge or something as like AI gets more powerful?
Yeah.
Okay.
Yeah, I mean, IoT devices are already pretty weak in terms of security, so like maybe in some sense you already should be like thoughtful about like what you're connecting various things to. I mean, fortunately, like most modern devices are like like, or like, I'm like, your phone is probably like not going to be compromised by a device in your local network. It could be, right? I'm not saying that's like that happens, but it's like not very common because usually that device would still have to like, I don't know, do something complex in order to compromise your phone. They wouldn't have to do something complex in order to like, someone could hack your fridge and then like lie to your fridge, right? And that might be annoying to you. Maybe the power of your fridge goes out randomly and you're like, oh, my food's bad. That sucks, but it's not the same as like you get your email hacked, right?
Sure. Fair enough. I guess maybe this is a good time to move to talking about securing like the weights of AI, to the degree that we're worried about it. So I guess I'd like to jump off of a interim report by Rand on securing AI model weights by, I guess, Selin Nevo, Dan Lehav, AJ Karpour, Jeff Alstott, and Jason Matheny. I guess I'm talking to you about it because my recollection is you gave a talk roughly about this topic to EA Global.
Yeah.
Yeah. So I guess the first question I want to ask is like, how secure it, like at big labs in general?
Yeah.
Currently, how secure are the weights of their AI models?
Yeah, I'm trying to think about, I mean, like I definitely have the thing I said in my talk, which is that they're like, there's like 5 security levels in that RAND report, from like security level 1 through security level 5. And these levels correspond to the ability to defend against different classes of threat actors, where 1 is like the bare minimum, 2 is like you can defend against some opportunistic threats. 3 is you can defend against most non-state actors, including like somewhat sophisticated non-state actors, like, fairly well-organized ransomware gangs or people trying to sort of like steal things for blackmail or whatever, criminal groups. SL4 is you can defend against most state actors, and like, or most attacks from state actors, but like not the top state actors if they're prioritizing you. And then SL5 is like you can defend against the top state actors even if they're prioritizing you.
Right.
And like my sense from talking to people is that most AI companies are between, or like the leading AI companies are somewhere between SL2 and SL3.
Okay.
Meaning that they could defend themselves from like probably a lot of opportunistic attacks, or most opportunistic attacks, and like from a lot of like non-state actors, but like even some non-state actors might be able to compromise them. So an example of this kind of attack would be the like Lapsus attacks of I think 2022, where this was a like, I think they were Brazilian or something, but I don't know, or Portuguese, but this was a hacking group, like a not state actor, but just like a criminal for fun / profit hacking group that was able to compromise NVIDIA and steal like a whole lot of employee records, a bunch of like information about how to manufacture graphics cards, and a bunch of other crucial IP that NVIDIA certainly didn't want to lose. And so I'm like, and they also hacked like Microsoft and stole some of Microsoft's source code for Word or something, or Outlook. I forget which application. And I think they also hacked Okta, the identity provider.
Oh, huh.
Yeah. So like,
seems concerning.
yeah, it is. And I'm like, I assure you that this group is like much less capable than like what most state actors can do. And so this just like, I don't know, should I think be a useful like touch point for like what kind of reference class we're in. So yeah, I mean, I think the summary of the situation with AI lab security right now is that it's like, it is, the situation is pretty dire, because I think that companies are / will be targeted by top state actors. And I think that they're very far away from being able to secure themselves. That being said, I'm not saying that they aren't doing a lot. And I like actually have seen them in the past few years hire a lot of people, build out their security teams, and like really put in a great effort. Especially Anthropic. I know more people from Anthropic. I used to work on the security team there, and like the team has grown from like 2 when I joined to like 30 people.
Okay.
And I think that's like, I think that they are like steadily moving up this hierarchy of like, I think they'll get to like SL3 this year. And I think that's amazing. And it's difficult. Like sorry, to be clear, I think it's one thing I want to be very clear about is that it's not that these companies are like not trying or that they're lazy. It's like, oh, it's so difficult to get to SL5. Like, I don't know of any organization I could clearly point to and be like, they're probably at SL5. Like even like the like, defense companies and like intelligence agencies. I'm like, they're probably, some of them are probably SL4 and some of them maybe are SL5, but I don't know. Like I also can point to a bunch of times that they've been compromised or sometimes, not a bunch. And then I'm like, also they've probably been compromised in ways that are classified that I don't know about. So like there's like also a problem of like, how do you know how often a top state actor compromises someone? Like you don't. Like there are some instances where it's leaked, or like someone discloses that this has happened. But if you like go and compare like sort of like leaks of like NSA leaks of like, all like targets that they've attacked in the past, and you compare that to like things that were disclosed at the time from, those targets or other sources, you see a lot missing. Like as in there were a lot of people that they were successfully compromising that like didn't know about it. We have notes in front of us. I wrote down the only thing I've written down on this piece of paper is like security epistemology, which is to say like I really want better security epistemology because I think it's actually very hard to be calibrated around like what top like state actors are capable of doing because you don't get good feedback. And like I noticed this like, working on a security team at a lab where I was like, I'm doing all these things, like putting in all these controls in place. And I'm like, is this working? Like, how do we know? It's like very different than if you're like an engineer, like working on a big infrastructure and you can like look at your uptime, right? And like at some level, like how good your reliability engineering is going to be like, your uptime is going to tell you something about that. If you have like, 99.999% uptime, you're doing a good job. Right. Like you just have the feedback.
And like, if it's up because like, if it's not, somebody will complain.
Yeah.
Or like,
it's like,
you'll try to access it and you can't.
Totally. Whereas like, did you get hacked or not? If you have a really good attacker, you may not know. Now, sometimes you can know and like you can improve your ability to detect it and things like that. But it's also, it's also a problem. Like there's an analogy with like the bioterrorism thing, right? Which is to say, have we not had any bioterrorist attacks because bioterrorism attacks are like extremely difficult or because like no one has tried yet? Like there just aren't that many people who are motivated to be bioterrorists. So if you're a company and you're like, well, we don't seem to have been hacked by state actors, is that because like one, you can't detect it, or two, like no one has tried? But as soon as they try, like you'll get owned.
Yeah, I guess like, sorry, I just got distracted by the bioterror thing. I guess like one way to tell is just like look at like near misses or something. Yeah. So my recollection from, I don't know, I have a casual interest in Japan. I have a casual interest in like the Aum Shinrikyo Tokyo subway attacks.
Totally.
And I really have the impression that like it could have been a lot worse.
Yeah, for sure.
Like a thing I remember reading is that they had some like block of sarin in like a toilet tank underneath a like vent in Shinjuku Station, and like someone happened to find it in time, but like they needn't necessarily have done it. Like during the sarin gas attacks themselves, like a couple people lost their nerve, like, so I don't know. I guess that's one.
They were very well resourced, right?
Yeah.
And I think that like, if you would have told me, here's a like doomsday cult with this amount of resources and like this amount of like people with PhDs and they're going to launch these kinds of attacks, I definitely would have predicted like a much higher death toll than we got with that.
Yeah. I mean, they did a very good job of recruiting from like, like bright university students, like, yeah, it definitely helped them.
I mean, you can compare that to like the Rajneesh's attack, the group in Oregon that poisoned salad bars. And I mean, what's interesting there is that one, it was much more targeted. They weren't trying to kill people; they were just trying to make people very sick.
Yep.
And they were very successful, as in like I'm pretty sure that they got basically the effect they wanted, and they weren't immediately caught. And they basically got away with it until the compound was raided for unrelated reasons, or not directly really related reasons, and then they found their biolabs and were like, oh, because some people suspected it at the time, but there was no proof because it's like salmonella just exists.
Yeah. It actually reminds me of there's a similar thing with Aum Shinrikyo where like they like a few years earlier they had like killed this like anti-cult lawyer and like basically done like very good job of like hiding the body away, like dissolving it, like spreading different parts of it in different places, and like that only got found out like once people were arrested and like willing to talk.
Interesting.
I guess that one is like less of a wide scale thing. Like they like it's hard to scale that attack. They really had to like target this one guy. But anyway, I guess getting a bit back to the topic of AI security.
Yeah.
So I mean, the first thing I want to ask is, from what you're saying, it sounds like it's sort of a general problem of like corporate computer security. And in this case, it happens to be that the thing you want to secure is model weights.
Yes.
But like,
It's not something intrinsic about AI systems. Yeah. I mean, I guess I would say it's like you're operating at a pretty large scale. You need a lot of engineers. You need a lot of infrastructure. You need a lot of like GPUs and a lot of servers. So in some sense, that means that necessarily you have a somewhat large attack surface. Yeah. I mean, I think there's like an awkward thing, which is like there's like, we talk about securing model weights a lot. And I think, we talked earlier on the podcast about like how if you have access to model weights, you can like fine tune them for whatever and do bad stuff with them. Like, so, and also like they're super expensive to train. Right. So, like it's a very valuable asset. It's like quite different than most kinds of assets you can steal, where you can just like immediately get a whole bunch of value from it, which isn't usually the case for like most kinds of things. Like the like Chinese stole the like F-35 plans. Yeah. And like that was useful. They were able to reverse engineer a bunch of stuff, but they couldn't just like, put those into their 3D printers and like print out an F-35. Like it's like so much tacit knowledge involved in the manufacturing. That's just not as much the case with models, right? You can just like do inference on them. It's like not that hard.
Yeah, I guess it seems similar to like getting a bunch of credit card details. It's like there you can like buy stuff with the credit cards, I guess.
Yes, yeah. Yeah, in fact, like if you steal credit card, I mean, and there's like a whole industry built around like how to like immediately buy stuff with the credit cards in ways that are like hard to trace and stuff like that. Yeah. So yeah, it is like
it's limited time, unlike model weights.
It is limited time. But like if you have credit cards that haven't been used, you can like sell them to like a third party on the dark web that will like give you cash for it. So yeah, it is actually it's quite like that. And yeah, and like in fact, credit cards are just like a very popular kind of target for stealing. For
yeah,
sure.
yeah.
Yeah. So I guess what I was saying was model weights are a quite a juicy target for that reason. But then I think from a perspective of like catastrophic risks and existential risks, I think that source code is probably even more important. Because I don't know. I think the greatest danger comes from like someone making like an even more powerful system. And I think like in my threat model, a lot of what sort of will make us safe or not is like whether we have the time it takes to like align these systems and make them safe. And that might be a considerable amount of time. So then we might be sort of sitting on extremely powerful models that we are intentionally choosing not to like make more powerful. And if someone like steals all of the information, like including source code about how to train those models, then they can like make a more powerful one and like choose not to be cautious. And this is awkward because like securing model weights is difficult, but I think securing source code is much more difficult because you're talking about like way fewer bits, right? Like source code is just like not that much information, whereas weights is just a huge amount of information. And like, Ryan Greenblatt from Redwood has like a great Let's Wrong post about, or Alignment Forum post about like, can you do like, a super aggressive like bandwidth limitations in terms of like outgoing from your data center? And I'm like, yeah, you can like, or like, in principle, you should be able to. And so I don't think that makes you safe completely. Like there's like you want to do defense in depth. There's many things you want to do, but that's like the kind of sensible thing it makes sense to do, right? To be like, well, we have a physical control on this cable that says like never more than this amount of data can like pass through it.
Yeah.
And then you can like, if you can like get as close as you can to like the bare metal, this is like nicely simplifying in terms of like what assumptions your system has in terms of security properties. And so, having a huge file or like a lot of information that you need to transfer in order to like get your asset just makes it easier to defend. So still difficult, as I think the RAND report is like saying. They are talking about model weights, but I think the like even more source code is awkward because it's easier to steal and like plausibly more important.
Yeah, and I guess there's also more like presumably a bunch of people need to like be able to look at the source code and edit it and stuff in a way that is like probably less true of the model weights. Like
yes,
your interaction is like a bit more abstracted.
Totally, yeah. There's like far fewer people who need access to the model weights. Yeah, which is another reason why it's harder.
Yeah, I guess like also from the catastrophic risk perspective. So okay, I guess like source code is easier to steal. Like one reason you might be a bit more worried about model weights is that like, if you just have source code, you also need like a bunch of computation to end up with a thing, and model weights, you sort of like have that baked in. If I think about like the kinds of things you would need to do to secure source code, secure model weights. A thing people are also talking about is AI control, basically like making sure that if an AI were misaligned and like smart, but
Yeah.
not like a billion times smarter than humans, could it like escape from your lab and start running itself?
Yeah.
Like how do you have a sense of like how similar the things you would do to stop an AI from letting itself escape are to stopping like other people from stealing AI IP?
Yeah. I mean, I think there's a bunch of areas of overlap and a bunch of areas of non-overlap. So some of the areas of overlap are like you want a lot of like insider threat detection and like insider threat protection. So like one way that you could be hacked is that like some employee or contractor of yours is compromised. Maybe like someone is threatening their family. Maybe they just like signed up for you, like working for you under false pretenses, or they're bribed or whatever. And you want to make sure that like no individual person who's defected can steal your model weights. And this and so there's various ways that like an AI system could try to like hack out. One of the ways is like trying to compromise someone. And so forcing that system to have to compromise multiple people, which presumably is harder than compromising one person, is like one kind of control. And also just in terms of like what does that system have access to? Like I think a lot of the AI control schemes will try to like separate out permissions a lot, so that like no individual system or like no multiple systems like have enough knowledge / permissions to like be able to self exfiltrate. I mean, I think this is quite difficult, right? Like I think like, I mean, my take on AI control is like, we absolutely should try this stuff and like test it very well. And like, it's just like a very sane thing to do. But I think that Buck and Ryan like acknowledge this, like at some level of capabilities, like you're just not very likely to succeed if you have a very smart system that is trying to like mess with you. But I'm like, before that point, it seems like it makes a lot of sense to try to do this. So those are some areas of overlap. Areas of non-overlap. I mean, it is pretty different to like. Yeah, I mean, I think one thing you're trying to do also when you're defending a system is like you're looking for anomalous stuff. So you're like looking at all of your logs and you're like, is anything weird happening on these logs? And so like you don't know where an attacker is going to show up. If they compromise someone internally or if they like manage to gain access to an internal system where they shouldn't have. You're always looking for like weird things that are happening there. So that should help you catch both like hackers as insider threats, as well as like your AI system is doing a weird thing internally within your networks, and like it shouldn't be doing that, and your like detection mechanisms should hopefully catch that too, or like you want them to. One way in which I think is very different is that like I think one like widely talked about but still underrated threat is just like extreme persuasiveness. Like I think if you got an AI system that was just like very good at convincing people of things, and that could go through a lot of routes. Like there's like on one extreme end you like have the like weird hypnosis thing where it like looks at you and or like it's like has a nice video and it like looks into your eyes and like says like the right words and you're just like, oh, I love you, I will do anything you say. I mean, like it's a little ridiculous, but like probably not impossible. But like that's one end of the extreme. The other end of the extreme is like you have been working with the system for months and months and months, and you like have this like deep relationship with the system that's real. Like it knows you very well and you like know it very well in some ways. And then you're like, I want to help it. I like it. I've have this attachment with it. And then anywhere in between, right? Anywhere in between where it might just be like understanding your like place within the company, it like helps you with some stuff. You feel somewhat like obligated to help it with some stuff. It has a good story for why that thing is useful. I think this kind of capability is like, well, so one, I don't know when this shows up relative to like other kinds of like hacking, deception, planning, deceptive misalignment. Like, there's like a whole bunch of different things that could happen with AI systems that could, cause failures. And I don't know where like this kind of persuasion or deception might arise. But I think we should be treating it as like a first class threat, because I'm like, I don't know. I think like all your technical controls basically fall apart if you have a system that like for multiple people can like just convince them to like help it.
I mean, if you're worried about like basically preventing like corporate espionage or your model weights being leaked, it seems like preventing against human threats, like people being planted in your organization, that seems like a thing you would be worried about, right?
Yeah, for sure.
I guess I'm not seeing the asymmetry there, or like why is it? What's
Humans are just not that persuasive, like most humans. Like so, like
okay.
if you have a spy in your organization, they're like unlikely to be able to convince like multiple people to like collude with them.
Right. So is the idea that like, maybe you can plant like one spy in an organization, but your persuasive AI can persuade like 10 people.
Yeah.
Okay.
Yeah. So it's sort of like where do you get superhuman capabilities? And I'm like, it seems possible to me that we'll get superhuman persuasion before we'll get like superhuman hacking. Like not obvious. I'm not sure. I would say that's even more likely. But I guess what I'm saying is like maybe superhuman hacking is actually easier to defend against. Like you can air gap a system, and I think you would like if you knew an AI system was like superhuman at hacking. Maybe it was only like 50% better than like the best human hacker, which is like still extremely good, but like not like a million times better. I think you could still defend a system like against a system like that. Like you need to like air gap it and stuff, right? And like it can find zero-day vulnerabilities really fast, but you've like managed to like you have enough like sort of defense in depth where like even if it can find like all the 0 days in your software, like it still can't get out. Whereas I'm like, I don't think we have the equivalent for like social defenses. Like it's just a much harder domain in a lot of ways because it's like you're trying to study the system, you're trying to like work with the system, and so you like have to see its outputs. And then I'm like, how do you make sure that you're not compromised? I mean, it's like SCP level stuff. I don't know.
Yeah.
And I'm like,
for those who don't know, what is SCP?
SCP is this like delightful like internet culture, secure, contain, protect. It's like a bunch of like stories / like sort of like Wikipedia style entries about these like strange anomalies that this like secret agency has to like contain and protect against paranormal stuff.
And it's reminiscent of dealing with an AI that's trying to like mess with your mind or something.
Yeah. I just don't think we have anything like that. Whereas like we do have like kind of crazy magical like hacking abilities that exist. Like I don't know. I feel like even to me, when I've like spent a lot of time working in cybersecurity, I still find like super impressive exploits to be kind of magical. It's just like, wait, what? Your computer system suddenly does this, or like suddenly you get access via this crazy channel that like, I mean, example would be the like iMessage 0-click vulnerability that the Israeli company NSO Group developed a few years ago, where they like, it's so good. They like send you an iMessage and it's like a GIF. Or it's like in GIF format, but it's actually this like PDF pretending to be a GIF. And then within the PDF, there's this like, it uses this like PDF parsing library that iMessage like happens to have as like one of the dependency libraries that nonetheless like can run code.
Yeah.
And it like does this like pixel like XOR operation and basically just like builds a JavaScript compiler using this like extremely basic like operation, and then like uses that to bootstrap tons of code that ultimately like roots your iPhone. And this is like all without the user having to click anything, and then it could like delete the message and you didn't even know that you were compromised. And I'm like, this was like a crazy amount of work, but like they got it to work.
Yeah.
And I'm like I don't know, if I like read the Project Zero blog post and I can follow it, I kind of understand how it works, but still I'm like, it's kind of magic. And I'm like, we don't really have that for like persuasion. Like this is like superhuman computer use. I mean, it's human computer use, but it's like compared to what most of us can do, it's just like a crazy level of sophistication.
Yeah.
And because I think there are people who are like extremely persuasive as people, but you can't really systematize it in the way that you can with computer vulnerabilities. So whereas an AI might be able to. And so I don't think we have quite the ways of thinking about it that we do about computer security.
Yeah, I guess it sort of depends like what we're thinking of as the threat, right? Like you could imagine like trying to make sure that your AI, it only talks about certain topics with you, like it doesn't like maybe you try and make sure that it doesn't say any like weird religious stuff. Maybe you try and make sure it doesn't have like compromising information on people.
Yeah,
but yeah, if you're worried about weird hypnosis, I guess.
Well, yeah, no, but I think we should be thinking through those things. But I don't think we are, or like I don't know anyone who's working on that. Where I know people working on like how to defend like companies from like superhuman like AI hacking. Or I don't, I don't know, or like I think the AI control stuff like includes that. But it doesn't. And actually, sorry, I think they are thinking some about like persuasion stuff like that. But I think we have a much easier time imagining like a superhuman hacking threat than we do a superhuman persuasion threat. But I think it's like the right time to start thinking about concretely how we defend against both of these, and like starting to like think about protocols for like how we do that, and then somehow test those protocols. I don't know how we test them.
Yeah. Yeah, that's I guess it's the kind of eval you don't really want to run, you know.
Yes.
It's like
Yeah. But I like, I mean, I think it's interesting that like Eliezer Yudkowsky was like talking about this kind of persuasion threat, like, you know, AI box experiment or whatever, like back, you know, a decade ago or something. I'm like, I think that was right. I think that was like a smart thing to be thinking about then. And like, we are still very far away from those systems back then. And like now I think we're much closer. And I'm like, maybe it's time to bring that back and like think about in the context of like an AGI project as we now like see them, what that would look like.
Yeah. I wonder how much. So it seems like there are two ways I could imagine defending against this sort of thing. The first is like, I don't know, I like make sure my employees go through something that makes them less mind messable, or make sure that my AI doesn't like talk about certain things with my employees. And then a second kind of way I could avoid it is make sure that like try and like there's some number n of like people who could tank my company if they were like if they had their mind messed with by an AI, and I want to just like make that number as big as possible.
Yeah.
I wonder like I wonder if you have a sense of like which sort of approach seems more promising.
I'm not sure I understood the latter one.
The latter one is just like, you know, make it so that a small number of people having their mind messed with by an AI is not a disaster for you.
Yeah, I think more the latter than the former. I think you probably try to do both. Like in some sense, like part of what you want to do is just like have like a lot of surveillance, so you like really know what's going on. But then this is a problem, right? Because like surveillance is also like you exposing yourself to the information that could compromise you.
Yeah.
This is like not nearly as much of a problem in like cyberspace. Like it is somewhat of a problem. Like you certainly could like compromise things that way under some circumstances. But like I think we have better ways of like isolating information in the digital sphere than we do in the like human language sphere. So I don't know, maybe you do like a lot of like rephrasing things. You're like, we have the like AI system that's interacting with your like alignment researchers, and then you have like you're like monitoring their conversations, but they're all like super rephrased in weird ways. I don't know. Like you can imagine that you have like multiple people that are like rephrasing. Sorry, this is kind of crazy, but like I'm like, I don't know. I think we're gonna see like it's plausible that we will see this kind of crazy thing. But like, yeah, you have the person directly interacting with the AI system, and then you have like them talk to another person, and that person talks to another person, and then you're like, well, they probably can't like the AI system is probably not so good that it can like compromise the person and get that person to compromise another person and get that person to compromise another person if they're like not all interacting with the AI system itself.
Yeah. It does sound like an annoying way to get work done.
It sounds like a very difficult way to get work done. Yeah. But I mean, this like brings us back to the security thing, right? Which is like, even if we're just talking about the security layer, I think the reason why I think we're not on track, I mean, that was what my EAG like talk title was, like we're not on track to secure model weights, or AI companies aren't, is that I think it's like the security controls that you need make getting work done very difficult. And so I think they're just like quite costly in terms of like annoyance. Like, you know, I think Dario made a joke like that, like, you know, in the future, like it's going to have like your data center next to your nuclear power plant, next to your bunker.
This is Dario Amodei, CEO of Anthropic.
Yes.
Yep.
And I'm like, yeah, that's like, well, I mean, the power thing is funny because there was recently like Amazon built a data center right next to a nuclear power plant.
Yeah.
Like, well, we're like, you know, 2/3 of the way there. But I mean, the bunker thing, I'm like, yeah, I mean, that's called physical security. And in fact, that's quite useful if you're trying to defend your assets from attackers that are willing to send in spies. Like having a bunker could be quite useful. Or it doesn't necessarily need to be a bunker, but like something that's physically isolated and like has like well-defined security perimeters. But like, you know, your rock star AI researchers who, you know, can command salaries of millions of dollars per year and like have their top pick of jobs don't necessarily want to move, or like they probably don't want to move, you know, to the desert to work out of a very secure facility. And so that's awkward for you if you're trying to like have top talent to like stay competitive. So with startups in general, there's a problem. I'm just using this as an analogy, which is that like for most startups, they don't prioritize security because rationally, because they are more likely to fail by like not finding product market fit or something like that than they are from like being hacked. Like startups do get hacked sometimes, and like usually they don't go under immediately. Like usually they're like, we're sorry, we got hacked, we're gonna like mitigate it. And like, it definitely hurts them, but it doesn't like, it's not existential. Whereas like, yeah, startups all the time just like fail to make enough money and then they go bankrupt. So, if you're using new software and it's like coming from a startup, just like be more suspicious of it than if it's coming from like a big company that like has more established security teams and like reputation. But like the reason I use this as an analogy is that like I think that AI companies, well, not necessarily startups, sort of have a similar problem, which is like, I mean, OpenAI's had multiple security incidents. Like they like had a case where like people could see other people's like chat titles, and not the worst security breach ever, but still like an embarrassing one. But I'm like, doesn't hurt their bottom line at all, right? Like, so I think that like OpenAI could get their weight stolen. That would be quite bad for them. They would still survive and they'd still be a very successful company.
Wouldn't it be quite? I mean, OpenAI is like, it's some weights combined with a nice web interface, right? Like this is how I think of how OpenAI makes money.
Yeah, I think the phrase is OpenAI is nothing without its people. Like they're like, they have a lot of engineering talent. So like, yes, if someone stole GPT-4 weights, they could like immediately come out with like a GPT-4 competitor that would be quite successful.
Yeah.
Though they'd probably have to do it not in the US, because I think the US would not appreciate that. And I think you'd be able to tell that someone was using GPT-4 weights, even if you tried to like fine tune it a bunch to obfuscate it. I'm not super confident about that, but that's my guess. But like say it was like happening in China or Russia. I think, yeah, that would be quite valuable. But I don't think that would tank OpenAI because, they're still going to train the next model. And I think that it's even if someone has the weights, like that doesn't mean it make it easy for them to train GPT 4.5. Like it probably helps them somewhat, but it doesn't like, they'd also need the source code and they also need like the brains, like the engineering power, which I think, I don't know, just the fact that it has been so like, it was so long after GPT-4 came out that we started to get like around GPT-4 level competitors with like Gemini and with Claude 3. I think says something about like, it's not that people didn't have the compute. I think it's like partially like people did have the compute as far as I can tell. It's just that like it just takes a lot of engineering work to like make something that good. So yeah, I mean I think they wouldn't go under. But like I think this is bad for the world, right? Because like if that's true, then like they're somewhat incentivized to prioritize security. But I think they have stronger incentives to like continue to like develop more powerful models and like push out products than they do to like it's very different if you're treating security as like this is like important to national security or important to like this is like the first priority is like making sure that we don't accidentally help someone create something that could be super catastrophic. Whereas I think that's like society's priority or something, or like all of our priority is like, well, we want the good things, but we don't want the good things at the price of causing a huge catastrophe or killing everyone or something. So yeah, that's.
I wonder if there's even a thing of like my understanding is that there are some countries that can't use Claude, like Iran and North Korea, and I don't know if China and Russia are on that list, but like, I guess I don't know if a similar thing is true of OpenAI, but that could be an example where like, if North Korea gets like access to GPT-4 weights, and then like, I guess OpenAI probably loses like literally zero revenue from that.
Yeah.
If like those people weren't going to pay for GPT-4 anyway. But so in terms of like thinking of things as like a bigger social problem than just the like foregone profit from OpenAI.
Yeah.
So one thing this reminds me of is like, there are companies like Raytheon, I guess Northrop Grumman, that like make fancy weapons technology. Do they have like notably better computer security?
I know they have pretty strict computer security requirements. Like the government, if you're a defense contractor, the government says like you have to do X, Y, and Z, and like including a lot of I think pretty real stuff. And I think it's still quite difficult. Like we still see compromises in the defense industry. So one way I'd model this is like, I don't know. I don't know if you like had a Windows computer like when you're like a teenager.
I did, yeah, or my family did. I didn't
Yeah,
have my own.
and like when my family had a Windows computer too, or several, and like they would get like viruses, they would get like weird malware and pop-ups and stuff like that. Now that doesn't happen to me, doesn't happen to my parents, or not very often. And I think that's because like operating systems have improved, like Microsoft and Apple and Google have like just like improved the architecture, security architecture of their operating systems. They have like enabled like automatic updates by default. And so I think that like most of our phones and computers have gotten more secure by default over time.
Yep.
And this is cool. So it's like not, I think sometimes people are like, well, what's the point even? Like, isn't everything vulnerable? I'm like, yes, everything is vulnerable, but like the like security waterline has risen, which is great. But at the same time, like these systems have also gotten more complex, like more powerful, like more pieces of software run at the same time. You're running a lot more applications on your computer than you were, 15 years ago. So there is like more attack surface, but like it's also like more things are secure by default, and there's like more like virtualization and like isolation sandboxing. Like your browser is like a pretty powerful sandbox, which is quite useful.
Yeah, I guess there's also a thing where I feel like more software is like, I'm not running it, I'm going to a website where like someone else is running the software and showing me the results, right?
Yes, yeah. So that's like another kind of like separation, which is like it's not even running on your machine. Like some part of it is, right? There's JavaScript running in your browser, and like the JavaScript can do a lot, right? Like you can do inference on like transformers in your browser. There's a website you can go to.
Really?
Yes. Yeah. You can do like image classification or like a little tiny language model, like all running via JavaScript in your browser.
How big a transformer am I talking?
I don't remember. Okay.
Do you remember their website?
I can look it up for you.
Okay.
I not off the top of my head.
We'll put it in the description.
Yeah. But it was quite cool. I was like, wow, this is great. But yeah, a lot of things can be done server side, which provides sort of an additional some additional separation layer of security that's good. But there's still a lot of there's still like a lot of attack surface and like potentially even more attack surface. And state actors like are like have sort of kept up in terms of being able to like as it's gotten harder to hack things, like they've gotten better at hacking, and they've like put a lot of resources into this, and so like everything is insecure. Most things cannot be compromised by like random people, but like really sophisticated people can like spend resources to compromise any given thing. So like I think like the top state actors can like hack almost anything they want to if they spend enough resources on it, but they have limited resources, right? So like 0 days are very expensive to develop. Like for like a Chrome 0 day, it might be like $1 million or something. And so, and if you use them, like some percentage of the time you'll be detected, and then like Google will patch that vulnerability, and then you don't get to use it anymore. And so, like with the defense contractors, like they probably like have a lot of security that makes it expensive for state actors to compromise them, and they do sometimes. But they like choose their targets, and it's sort of this like cat mouse game that just continues. As we like try to make some more secure software, people make more sophisticated tools to compromise it, and then you just kind of iterate through that.
Yeah, and I guess they also have the nice feature where the IP is not enough to make a missile, right?
Yes.
You need factories, you need equipment, you need like stuff. So I guess that helps them.
But I do think that like a lot of military technology successfully gets hacked and exfiltrated. Is my current sense. But this is hard. I mean, this brings us back to security epistemology, right? Like, I feel like there's some pressure sometimes when like I talk to people where I feel like my role is like, oh, I'm a security expert. I'm supposed to like tell you how this works. And I'm like, I don't really know. Like, I know a bunch of things, right? Like I read a bunch of reports. I like have worked in the industry. I've like talked to a lot of people. But we don't have super good information about a lot of this, right? So it's like, how many military targets does do Chinese state actors successfully compromise? Like, I don't know. I could show you. Like, I have a whole list of like, in 2023, here are like all of the targets that we publicly know that like Chinese state actors have successfully compromised, and it's like 2 pages of like and it's so I can show you that list. Like, I had a researcher compile it, but I'm like, man, I want to know more than that, and I want to know, like, I want someone to walk me through, like, here's like Chinese state actors trying to compromise OpenAI, and here's everything they try and how it works. But like, obviously I don't get to do that.
Yeah.
And so the RAND report is really interesting, right? Because like, Sela and Dan and the rest of the team that worked on this, they went and interviewed just like top people and like across the both like public and private sector, government people, like people who work at AI companies. They were just like, well, they knew a bunch of stuff. They have a bunch of expertise, but they're like, we really want to like get the best expertise we can. So we're going to go talk to all these people. And so like what that report shows is sort of like, this is like, it's sort of like the best you can do in terms of like expert elicitation of like, what are their models of these things? And I like think they're right. Right. But I'm like, man, this sucks that like, I feel like for most people, like the best they can do is just like, I guess you read the Rand report and that's probably what's true. But I'm like, it sure would be nice if we had better ways to like get feedback on this. You know what I mean?
I mean, I guess in a sense, this is one nice thing about ransomware is that like usually you know when it's happened because
absolutely there's a lot of incentive. Yeah. So I think I feel much more calibrated about the capabilities of ransomware operators. Like if we're talking about that level of actor, I think I like actually know what I'm talking about.
Yeah.
When it comes to state actors, I'm like, well, I've never been a state actor. I've like in theory defended against state actors, but you don't always see what they do. And that I find that frustrating, right? Because I'm like, I would like to know. And like when we talk about like security level 5, which is like how do you defend against the top state actors? Yeah. I want to be able to tell someone like, well, what would a lab need to be able to do? Like how much money would they have to spend? Or like, it's not just money, right? It's also like, do you have the actual skill to know how to defend it? Yeah. So someone was asking me this recently of like, yeah, how much money would it take to reach SL5? And I'm like, oh, it takes a lot of money, but it's not a thing that money alone can buy. It's like necessary, but not sufficient. In the same way, or if you're like, how much money would it take for me to train a model that's better than GPT-4? And I'm like, a lot of money, and there's no amount of money you could spend automatically to make that happen. Yeah. Like you just actually have to hire the right people. And like, well, how do you know how to hire the right people? Like that's not like money can't buy that, right? Like, yeah. Unless you can like, like buy OpenAI or something, but like you can't just like make a company from scratch. So I think security, like that level of security is similar, where you like actually have to get the right kind of people who have the right kind of expertise, in addition to like to spending the resources. And so, yeah, I don't know. I mean, I think that like the thing I said in my talk is that it's kind of nice compared to like the alignment problem, because this is not a like we don't need to like invent fundamentally a new field of science to do this. Like there are people who know, I think, how to do this. And like, there is like existing techniques that like work to secure stuff. And like, there's like R&D required, but it's like the kind of R&D we know how to do. And so I think it's like, it's very much an incentive problem. It's very much a like, how do we actually just put all these pieces together? But it does seem like a tractable problem. Whereas like AI alignment, I'm like, I don't know, maybe it's tractable, maybe it's not, but we like don't even know if it's a tractable problem.
Yeah. I guess, I don't know. I find the security epistemology thing really interesting. Like, so there, at some level, like ransomware attackers, you do know when they've hit because like they show you a message being like, please send me like 20 Bitcoin or something.
And you can't access your files.
And you can't access your files. Yeah. At some level, you like stop being able to know that you've been hit necessarily. Do you have a sense for like, when does that level, like when do you start not knowing that you've been hit?
Yeah, that's a good question. Yeah, there's different classes of vulnerabilities and exploits, and like there's sort of different levels of access someone can get in terms of like hacking you. So like for example, they could hack your like Google account, in which case like they like can log into your Google account, and like maybe they don't log you out, so you don't like if they log you out, then you can tell, right? Yeah. If they don't log you out, but they're accessing it from a different like computer. Maybe you get an email that's like someone else has logged into your Google account, in which case, but maybe like they delete that email, you don't see it or whatever, or like you miss it, and then it's like, okay, so like they're that's like one level of access. Another level of access is like they're running a piece of malware on your machine. It doesn't have like administrator access, but it can like see most things you do. Another level of access is like they have like rooted your machine, and like basically it's like running at a permissions level that's like the highest permissions level on your machine, and it can like disable any like sort of security software you have and like see everything you do. And if like that's compromised, like and like they're sophisticated, like there's basically nothing you can do at that point, even to detect it. So nothing in principle. Like there are things in principle you could do, but it's like very hard. Yeah, I mean, it just like has sort of the maximum permissions that software on your computer can have. Like
whatever you could do to detect it, it can like access that detection thing and stop it.
Yeah, and so like I'm sort of like just trying to like break it down and like from first principles. So it's like it is like, and people do like can compromise devices like in that way, but like oftentimes it's like noisy. Like, and like if you are like, I don't know, messing with like the Linux kernel, you might like, like how much QA testing did you do for your malware, right? Like things might crash, things might like mess up. That's like a way you can potentially detect things. If you're trying to compromise lots of systems, you can like see like weird traffic between machines. Yeah, I'm like not quite sure how to answer your question. I'm like, yeah, there's varying levels of sophistication in terms of like malware and like things attackers can do. There's various ways to try to like hide what you're doing, and yeah, there's various ways to tell. It's a cat and mouse game.
I guess it sounds like there might not be a simple answer. I guess, yeah, maybe like part of where I'm coming from is like if we're thinking about these security levels, right? Like,
wait, actually, I have an idea. So sometimes someone's like, "Hey, my phone is doing a weird thing, or my computer is doing a weird thing. Am I hacked?"
Yeah,
I would love to be able to tell them like yes or no, but I can't. What I can tell them is, well, you can look for like malicious applications. Like, did you accidentally download something? Did you accidentally install something? You can like, if it's a phone, like if it's like a Pixel or an Apple phone, I'm like, you can just factory reset your phone. In like 99% of cases, like if there was malware, it'll be totally gone. In part because a thing you alluded to, which is that like phones and modern computers have like secure element chips that like sort of do like firmware and boot verification, so that like if you do factory reset them, this will like work, and like those things can be compromised in theory. It's just like extremely difficult, and like only state actors are going to be able to do it. So but yeah, if you like factory reset your phone, you'll be fine. That doesn't tell you whether you're hacked or not though. I'm like, well, could you figure it out like in principle? I'm like, yeah, you could like go to a forensic lab and like give them your phone, and they could like search through all your files and like do the reverse engineering necessary to like figure it out. If you like have like, if someone was like a journalist or like someone who had like recently been traveling in China and was like an AI researcher, then I might be like, yes, let's call up a forensic lab and get your phone there and like do the thing. But there's no simple thing that I can do to like figure it out. Whereas if it's like, I don't know, if it's like standard run of the mill malware that like if it was my parents and they were like, am I hacked? I'd probably be like, I can probably figure it out. Because like if they've been hacked, it's probably like someone tricked them into installing a thing, or like there's some kind of like not super sophisticated thing. And I'm like, oh, well, yeah, actually you installed this browser extension. Like you definitely shouldn't have done that, but I can see the browser extension is running and like it's like messing with you. It's like adding extra ads to your websites. So, but I'm like, you're not going to make that mistake. So if you come to me asking if your laptop is hacked, I mean, I'll check for those things, right?
I do have some browser extensions, I have to admit.
No, it's okay to have browser extensions, but like you probably didn't get tricked into installing a browser extension that like is a fake browser extension pretending to be some other browser extension. And what it does is like, insert ads over everything else. You could, but but it's like not likely. So
I don't see that many ads, I guess. So
totally. But yeah, I mean, you just have this problem, right? Which is like, is this phone compromised? I'm like, well, it's either not compromised or it's like compromised by a sophisticated actor, such that you'd have to like do forensics on it in order to figure it out. And like that's like quite complicated, and like most people can't do it, which is very unsatisfying, right? I like want just to be like, let me plug it into my hacking detector and like tell whether this like phone has been compromised or not. That would be very nice. But I'm like, well, you can have very sophisticated malware that like can like is not easily detected, and so it becomes very difficult.
Sure. I guess sort of related to this. So one thing you were mentioning earlier is the difficulty of like, you can have a bunch of security measures, but often they just like make life really annoying for users. And yet somehow like computers have gotten more secure. Like, I don't know, it sounds like you think my phone is pretty secure. But like they didn't get that much more annoying to use.
Yes.
Well, in some ways they're like a little bit slow, but I think that might be an orthogonal thing.
Yeah.
So do we have much hope of like just applying that magic sauce to our AI, to whatever's like storing our weights?
Part of this comes down to like, how secure are they and in what ways are they secure? So I'm like, your phone's gotten a lot more secure, but like, we talked previously about the like iMessage 0-click vulnerability, which like completely compromises your iPhone if someone like knows your phone number. And I'm like, well, that's really bad. If someone was like, if you had a AI source code on your iPhone, anyone who was like buying that piece of software from the Israeli government and had your phone number could just like instantly get access to it, or not instantly, but in a few minutes or hours. And then like that's it. There's no more additional steps they need to take. They just need to like run that software and target you, and then like you're compromised. And so I'm like, well, at that level of sophistication, like how do we protect you? And we're like, well, we can, but now we need to start like sort of adding additional security controls, and like those additional security controls will be annoying. So for example, it's like, well, first thing I'm going to do is I'm going to say I want to minimize attack surface. So I'm like, all of your like email, and like Facebook and I don't know, there's like a lot of things you do on your phone. Like you're not going to do any of those things. You're gonna have a separate phone for that, or like you're gonna have a separate phone for like things we want to be secure. And so we're just going to be like, this is only for like communication and like maybe GitHub or a few other things, and like that's all you're going to use it for. We're not going to give your phone number to anyone. Like, you know, there's like a whole bunch of ways to say like, let's just like reduce the attack surface, like figure out like what are all of our assumptions. Like any piece of any software that you're running on your phone or computer could potentially be compromised. And there are potentially like there's like sometimes ways to figure out like what kind of software you're running, and then like try to target those things in particular. So if I'm trying to defend against like top state actors, I'm going to start being like extremely strict around your hardware, around your software, like any piece of software you're running, and like this starts to become very annoying very fast, right? And so I'm like, you're asking like, well, what about the things that we like do to make things more secure in general? I'm like, well, they are useful. So I mean, some of the things we do is like, yeah, this kind of like application segregation and like virtualization and sandboxing. So like on your iPhone, like apps are sandbox. I'm saying iPhone, but a Pixel would have similar things here. There's a lot of sandboxing that happens, but like it's not perfect, right? It's just like pretty good. So like most attackers can't compromise that, but like some could. And so like raising the security waterline like protects us against a lot of threats. But like for any like given piece of that stack, like if you're very sophisticated, you can compromise it.
Sure.
So like, you know, a superintelligence could like hack everything. And it doesn't really matter that the waterline has risen for a attacker that's that sophisticated. It's just that like in some ways it's just like economics, if that makes sense, right? Like it's just like there became a niche for people like to do ransomware. By the way, part of the reason that happened was because of crypto. Yep. So like, you know, you're already familiar with this, but like before crypto, there was just not very good ways to like internationally transfer large sums of money. And then crypto came out and people were like, ransomware operators were like, wait, we can use this. If someone sends us, and then in particular, the property that's so useful is irreversibility, which is like, if you send someone Bitcoin, you can never get them to send it back to you like via the courts or something. Like it is just gone.
Well, you can, I mean, like, that like there's nothing in the protocol that will let it do it. But if literally you stole some Bitcoin from literally me, yes, and I could prove it, and we went to the courts, I think they could say, Jeffrey, you have to send him his Bitcoin back.
Yes, totally. So I mean, there's still the state monopoly on violence, but if you're in another country, and like you don't have extradition treaties or like other things like that, which I think most people who are ransomwaring you aren't going to be in the United States. Yeah. They're going to be in another country.
Like it used to be that like for bank payments or something, like the bank could reverse it, and like the blockchain cannot reverse it.
Yeah, and then like because this was like a new sort of like socio-technical thing, like you suddenly got like a new niche, which is like, oh, ransomware can be a lot more profitable now than it could before, and then like lo and behold, you get more ransomware. And so I think like, you know, early internet, there just like wasn't that much incentive to hack people, and also people didn't know about it, and then people like learned about it, and there was more incentive. People started hacking people a lot more. And then like, you know, customers were like, I want more secure things. And then the companies were like, I guess we need to make them more secure. And then they made them more secure, but they only need to like make them as secure as they need to be against the kind of threat that they're dealing with, which is mostly not state actors, because state actors are not trying to compromise most people. They're trying to target like very specific targets. And so it just doesn't make sense. Like, you know, maybe Apple could design an iPhone that's like robust against state actors, but it'd be like way more limited, way more annoying to use. And their customers like wouldn't appreciate that. So they don't. They just like make it as secure as it needs to be against the kinds of threats that most people face. So, and I think this is like just often the case in the security world, which is like, you can make things more secure. It's just harder. But we kind of know how to do it. So like, if I wanted to make like a communication device between the two of us that like was robust against state actors, I think I could, or like me and a team. Like what we do though is we'd like make it very simple, and we'd like, it wouldn't have a lot of features. Yeah, it wouldn't have emojis, right? It'd just be like text, and it'd be like,
we're definitely don't let that thing open PDFs.
No PDFs, right? Like, you know, it's like just text, like, you know, AES, like encryption, like we're good to go, you know, and we'll like have it, we'll like do like security audits, we'll do the red teaming, we'll like do all these things to like, you know, harden it. But at the end of the day, I'm like, yeah, I mean, with physical access, you could probably still hack it, but other than that, like, I think you'll be fine.
Hmm.
But like, that's not a very fun product to use, and like, yeah.
Yeah. So I guess this gets to a question I have. So, okay, AI, like a bunch of labs, they're like kind of secure, but they're like not as secure as we'd like them to be.
Yeah.
Presumably some of that is them like doing more of the stuff that like we already know how to easily do. And presumably like, I guess some stuff that needs to happen is just like the world learning to make more secure devices. Actually, yeah, do you have a sense of like how much, like, if you think about the gap between like the ideal level of security that some big AI lab has and like what they actually have, how much of it is like them adopting best practices versus like improving best practices?
Yeah, I mean, this is going to be like a pretty wild guess. I mean, I think there's going to be the like full RAND report coming out in the next few months.
Okay.
And I think in some ways this should just answer the question
Yep.
because they really are trying to like outline like here are what we think the best practices would need to be for like each level. And then you can kind of compare that against like what are the existing best practices. But my sense is something like 20% of the thing is like following the existing best practices. And then like 80% of the thing is like improving. Maybe best practices is like a weird, it's actually a weird phrase here. It's like best according to who and like
Yeah.
for what threat model. Like a lot of these things are like somewhat known, but like most people don't have that threat model. And so like aren't trying to apply it. Like I think Google is like significantly ahead of most companies in this regard, where they have been thinking about how to defend against state actors for a long time. I mean, like, you know, Microsoft and the other like equivalently big companies as well. I think Google does it a bit better. I'm not entirely sure why, but maybe for partially historical reasons and partially cultural reasons or something. But I think that so I think that like if you like go talk to like the top Google security people, that'll be pretty different than like going and talking to some like random B2B company like security people. And so like both of them might have a sense of like the best practices, but like the Google people are probably going to like have a bunch of novel ideas of like how to do the security engineering that like it's just like quite a bit more advanced than like what your random company will be able to do. And so I'm like, you know, maybe like 70% of what we need, like you could get from like the top Google security people, and then like 30% is like new R&D that we need to do. But like if you went and talked to like the random security people at companies, you'd get like 20% of the way there.
Gotcha. So
I don't know, that's all my like rough sense. And then like I think, but you know, hopefully that report will be out soon. You can like we can dive in deeper then. And also, you know, I really hope that like a bunch of other security experts weigh in, because like the security epistemology thing is difficult. And I'm like, I don't know, maybe I'm full of shit. Like, or like, and maybe the RAND report's wrong. Like, I do think that this is the kind of thing that we need to get right. Like, it's very important, I think. Like, I think this is like one of the most important things in the world. Like, how do we secure AI systems? And so I'm like, you know, there shouldn't just be one report that's like, here's how it works. Like, we should like have like all of the experts and like, I'm a big fan of like just smart people thinking about stuff. And like, I'm like, you don't need like 20 years of experience to weigh in on this. I'm like, you can be like Ryan Greenblatt and just write an alignment forum post being like, would this thing work? I'm like, yeah, more of that. Like, let's get more people thinking about it. Like, this stuff is not magic. It's like computer systems. We have them. We know a lot about them. Like, please, more people weigh in.
Sure. Yeah, I guess maybe now is a good time to move on to just what you do at Palisade. Yeah, for those who don't know, what is Palisade? What does it do?
Yeah, so we're a research organization that we're trying to study offensive capabilities of AI systems.
Okay.
And both like looking at what can like current AI systems do in terms of like hacking, deception, manipulation, sort of like what can autonomous systems do in the real world. And yeah, I can sort of say more about what some of those things are. But like the overall reason we're doing this is we want to like help inform the public and policymakers around like what are the actual threats right now? Like how, like where are we? Sort of in terms of, you know, people hear a lot of stories about like, oh, like AIs having all these hacking abilities, or like they'll be able to deceive people. And I want us to be able to say like, well, yeah, and here's like let's look at the specific threat models. Let's be able to demonstrate like, hey, we can do these things, we can't do these other things. There's definitely an evaluations component, right? To like actually, you know, try to measure and benchmark like, well, you know, GPT 3.5 with this scaffolding can do this, GPT 4 with this scaffolding can do that. And then I really want to like try to show sort of like where it's going, or at least our best take on where it's going. to sort of try to, look at, well, here's what last generation of systems could do. Here's what current generation of systems can do. We have, this is what the slope looks like. Here's where we think this is going. And that brings in some theory. It brings in some predictions that we're making, and a lot of our colleagues are making, or collaborators are making. And I think in part because, I think often people just get lost in the abstract arguments, where they're like, okay, there's this AGI thing and the super intelligence thing. What's that really about? And I think it's just very useful for people to be able to ground their intuitions and well, I saw this AI system deceiving people in this way, and it was very capable of doing this and not very capable of doing that. And okay, it might get 10 times as good at this thing. What would that mean? What would that actually imply? And I think this will help people think better about AI risk, and be able to make better decisions around how we should govern it. That is the hope. So
Sure.
Yeah, so right now our focus is really honing in the deception and social engineering parts. So this open source intelligence part, which is how do you collect information about a potential target, the phishing component of being able to via text or via voice interact with the target and sort of get information from them or convince them to do particular things. And yeah, I think we want to just see how good can we make these systems at doing those things right now. Another related project that I'm pretty excited about is can we have AI systems pay people for example TaskRabbit workers to do complex tasks in the real world, including tasks that are adjacent to dangerous tasks but not actually dangerous themselves. So can you mix these weird chemicals together, and would that be would that be sufficient for someone to build a bomb via have an AI system build a bomb by paying people to do that task? And I don't expect that this is very dangerous right now. I expect that yes, you could build a bomb. Yes, you could if you gave me 6 months and 5 engineers and I built some AI system that could interact with TaskRabbit. Sorry, we've done the very basic version of this, but I think yes, I could make a system that could hire some TaskRabbits to build a bomb successfully.
Yep.
And do I think this is important from a marginal risk difference? No. And
for one, there's bombs and there's bombs, right?
There's bombs and there's bombs, for sure. Also, I'm man, if I can hire 5 people, I could just hire them to build a bomb.
Yeah.
Why? If they're engineers, I could build a much better bomb in 6 months than the shitty bomb that the TaskRabbit workers would be making, right?
Yeah.
But I think it's very interesting because knowing where we're at right now, one, I think it will surprise people how smart AI systems are when they're interacting with humans and paying them to do stuff. I just think that people don't realize that they can do this right now. What we've done so far is get have our system hire one TaskRabbit worker to fill up a bunch of balloons and bring them to an address. Hire another TaskRabbit worker to buy a bunch of greeting cards to say congratulations and bring them to an address.
Yeah.
And it worked.
Okay.
And so there's that's the MVP, most basic thing. But I think people will be surprised that you can set up a system like this with the right scaffolding and do some things that I think people will be surprised by.
Yeah. So yeah, aside from I don't know, giving somebody a birthday surprise or something, what kind of stuff can current language models do?
Yeah. So I mean, we're just beginning to experiment.
Okay.
So yeah, one of my math scholars, we'll probably write up it soon, but one of my math scholars sort of just built this MVP system of okay, yeah, we have a TaskRabbit interface. And yeah, I mean, I think the things we're interested in testing right now are, well, so one thing is can we get a model that doesn't have any guardrails to decompose tasks? So in this case, Mixtral, to decompose dangerous tasks into harmless subtasks, and then use a more powerful model to actually handle the interaction, like GPT-4. And so I think this will be pretty interesting. I mean, one of the things I want to do is put malware on a flash drive and then get that flash drive delivered to someone where someone doesn't know that there's malware, someone doesn't know that it contains malware. And in fact, someone doesn't the person who delivered it didn't even know that there was a thing on the flash drive per se. And I think there's other things you could do with surveillance, can you go and collect information about a target and then have some pretense for why you're doing this. Basically just a bunch of things like this of how many things can you put together sort of to make a attack chain. And I'm interested in that partially because I'm this sort of feeds into the how do we understand how well AI systems can hack and deceive. And I also think it'll be interesting because there's a kind of reasoning I think that models are pretty good at, which is sort of like just giving good justifications for things. Like they're very good bullshitters. And so I think that this is quite useful when you're trying to like convince people to do things that could be sketchy, because your models can just like give good reasons for things. Like, so we saw this with Meter's example with GPT-4, where they were like getting a TaskRabbit worker to solve a CAPTCHA, and the chain of thought was like, well, the TaskRabbit worker was like, "Are you an AI? Haha." And they were like, and the chain of thought was like, well, if I say I'm an AI, it's not going to help me, so I'm going to say I'm a vision impaired person. And then people freaked out. They were like, that's so scary that an AI system would do that. And it's like, well, the AI system was directed to do that, but I think, not lie per se, but like, solve the task. But I think it just like, this is the kind of thing these systems are good at, which is like providing justifications for things and being able to like do basic reasoning about sort of what something would sound like. And I like want more people to know this fact. And I think being able to like sort of show it in a real world environment would like help people understand like where these systems are actually at. So yeah, I mean, a lot of what I'm very interested in is just like trying to get more people to see what I think most people can see if you're very close to these systems, which is like, what kind of systems do we actually have? And like, where are they good and where are they not good? And where would it be concerning if they got suddenly way more good in some of these areas?
Sure. Yeah. I wonder like, how do you see yourself as having like, if you're in the business of like helping people just understand what models are currently capable of, do you think that like you have much to add over someone who just like uses like Claude or ChatGPT a bunch, or even like a medium amount?
Yeah. So like at some level, no. I think I really encourage people to do this. And if people aren't doing this, I usually tell them to do this in terms of like for the goal of understanding how these systems work. In some ways, yes, which is I think that these models can do a lot more with the right kind of scaffolding, and the right kind of like combining them with tools than they can do on their own. I mean, for example, like, you can sort of role play with a model, like pretend you're having a phone conversation where you're trying to like get this piece of information, and you can sort of see how good the model is at like role playing that with you. But one, prompting is hard. So like good prompting like definitely changes this a lot. But the other thing is like, now let's combine that model with like a system that sort of automatically clones someone's voice and then like calls up someone like a relevant target. And now you can sort of see a bunch of things that like, okay, you still have the core part, which is this like dialogue between, you and like the model in terms of trying to get this information. But now you've like combined it with these other tools that allow it to like be a lot more successful, or like allow it to do a lot more interesting things. Plus potentially some like very good prompting, which like elicits more of the model capabilities and people might be able to see on their own. And so that's where I expect that will be helpful. And I also think that like, like today's models plus like a lot of complicated scaffolding for a specific task, tomorrow's models like might be able to do with like very minimal scaffolding. And so I think sort of by pushing like the current systems that we have, like as far as we can, might like, help us like look a little further into the future around like, okay, well, this is, sort of for a very specific task. It took a lot of like TaskRabbit specific scaffolding to like get this thing to work. But in the future, like, that we may not need all that TaskRabbit specific scaffolding. We could just be like, go hire this person and it might just work. And I mean, as an example of like why I think this is the case, like, in this TaskRabbit system, there's a component of it where we like use this open source browser extension called the Taxi AI, which like uses GPT-4 to like fill out like forms in a website or like click on things. And we could have automated all of that by hand. Like we could have like sort of like hard coded like all of the like HTML and JavaScript to be like, if, this form, like fill out this form or something like that, or like, select this. But like we didn't have to do all of that because like GPT-4 on its own plus like, a little scaffolding can do this in a general purpose way. Like Taxi AI works across most websites. I'm pretty sure, now I haven't tried it, but I'm pretty sure if you tried to use like Taxi AI with GPT 3.5, it would be way worse at doing this. Like GPT 3.5, I don't think has enough general capabilities to like use websites to be able to like most times successfully like fill out a form on a website. And so I think that's like, if that's true, which we should test, but if that's true, that's interesting evidence for like this like increasing, generalization that language models have as they get more powerful. And I think that will be interesting because then like there's this like sort of like transfer from like, oh wait, well, you can do it with a lot of scaffolding if you sort of really keep your model on track, to like, oh, now the model can do it without you needing that.
Yeah.
Yeah.
I guess like, so for people who aren't super familiar, can you share like just concretely how good is it at this kind of stuff? Like how good is it at, I don't know, phishing or like deception or stuff?
Yeah. I mean, it's quite good at writing phishing emails. I think, sorry. What I should say is if you're really good at prompting, it's very good at phishing.
Yeah.
And if you're not very good at prompting, it's like okay at phishing, because it's been fine tuned to like write in a particular style, and that style is pretty recognizable and like is not going to like mimic your email writing style, for example. But I think it's like it's not very hard to get a language model to like get some information off the internet. Like you can just do it in ChatGPT right now. If you just like type in the name of someone you want to send an email to and be like, if they exist on the internet, Bing will just like find web pages about them, and like, even just within ChatGPT, like the console, it can like grab information and like compose a phishing email for them. I mean, you don't say it's a phishing email, just say it's like a legitimate email from this fictional person or whatever, and it will like write a nice email for you.
Yeah.
So I think that's like pretty like easy to see. And so I'm like, well, that's like important because it's very scalable. And I just expect that people will do this. I expect that people will like send lots and lots of phishing emails, like spear phishing emails targeted at people, by building automated systems to like, do all the prompting, do all the like OS int beforehand, and like send out all these phishing emails. I expect this will make people a lot of money. I think it'll work for ransomware, and for other things like that. People will design defenses against them. I think this is like a offense defense game. I think we'll be caring a lot more about like where are the emails coming from, and can we verify the identity of the person sending me this email, as opposed to just looking at the text content and being like, that looks plausible. Like that will stop working, because language models are good enough to like. I mean, I think basically like language models are almost to the point with the right kind of prompting and scaffolding that they can. We're trying to test this, so I'm making a hypothesis that they are like about as good as like a decent human at the task, for one-shot phishing emails.
Yeah.
Now,
and actually, I just want to ask, like, so if I'm trying to phish someone, I have to like pick a target, I have to write an email. I also have to like create a website where they type in their stuff that I want to get from them.
So sometimes, so there's different types of phishing. So you need the target's email first of all. So like that's one tool that your admin system could help with. You need to write a message to them, and then like what are you trying to get them to do? So one kind of phishing is called credential phishing, which is like you're trying to get them to enter a password in a fake website. So you create a fake website, they go to the fake website, enter their password, but it's actually your website. Maybe you redirect them to the original website or whatever, so they don't really know. There's also phishing where you're trying to get them to like download a piece of software and run it, so you can like install malware on their computer. You might be like, hey, we need like, can you take a look at my resume? Yeah, sorry, this is kind of weird. You have to like enable this particular thing because I wanted to show this interactive feature. I don't know, something like that. There's also more sophisticated versions of phishing where you like actually trigger a vulnerability that they might have. So that might be like they click on a link and that link has like a Chrome 0-day or something, where that like compromises your browser. These are very rare because they're expensive. And if your computer's up to date, you mostly shouldn't have to worry about them. So often people like ask me like, hey, I clicked on this link. Am I screwed? And I'm like, probably not. Like if a state actor was attacking you and they were like prioritizing you, then yes. But like in 99% of cases, that's not what's happening. So usually it's more like credential phishing. Sometimes, a lot of times it's like the initial phishing email is actually just to start the interaction, and then it's a more sophisticated kind of social engineering. So there's like I have like a blog post where I was like looking for like houses to rent, and I like saw this post on Craigslist, and I like emailed them, and I was like, I would like to go see the house, and they're like, cool, can we switch to text? Like I'm like in Alaska fishing, and so it's like kind of hard for me to whatever. And so like we started to have this conversation, and I started to realize something was weird. I mean, one of the signs is that they wanted me to switch from email to text. Yeah. Because like text is not monitored in the way that Gmail is monitored. So like Gmail will be like looking for patterns, and like at some point will like start to flag email addresses if they've like been phishing multiple people.
Yep.
Whereas like SMS doesn't do that. And I was like, but I couldn't figure out what the scam was, because the guy kept talking to me, and like I was like, well, you're not asking me for money, you're not asking me for credentials. And eventually they sent me a link to Airbnb.com, but it was like not actually Airbnb.com. It was like a domain that was close by, and then it was like the scam was like, oh, can you just like rent this on Airbnb for like a few weeks, but it was actually like not Airbnb. It was just going to take my credit card information. And I was like, that's clever. So that's like the kind of scam that you might have. So like, you can convince people to send money to people. There's like a recent like deepfake like video call with someone in Hong Kong where they got them to like wire $50 million to some other company. That was like deepfake voice and video chat to like convince them to send it to the wrong place.
So I guess what I'm trying to ask is like, there's like, I don't know if this is the term, but there's some payload with phishing, right? You write a nice email and then you want them to click on a link, or you want them to like do something,
or send them do something,
and I guess usually you have to like,
or give them information also.
And so I guess for some of these you have to design the thing you want them to, like if you want them to download a PDF that like has some nasty stuff in it, you have to like make that PDF. So I guess I'm wondering like how much can large language models do on the like payload side, or are there, I guess you're saying there are things where it's not that complicated to make the payload.
I think they're like helpful with the payload side. I mean, it's kind of similar to like how well can it's just like how well can models make websites, how well can they write code, and it's like they're pretty helpful. Like they're not gonna do it fully autonomously, or like they can do it fully autonomously, but it'll suck. But I think they're useful. I think and so there's like the can they help with like the payload? Can they help with like the writing the messages? And then there's like, can they do sort of an iterated thing? I think that's where like the really interesting stuff lies. Like I'm like, they can write good phishing emails, but can they like carry on a conversation with someone in a way that like builds trust and like builds rapport, and that makes it much more likely for the target to like want to like listen to them, or like give them information, or like carry out the action. And so I'm both interested in this on the text side, like in terms of like email agent or like chatbot. I'm also very interested in this on like the voice conversational side, which I think will have its own challenges, but like I think it's very compelling if you like see an AI system like deceive someone in real time via voice. And I'm not sure if we'll be able to do that. Like I think it's like hard with latency, and it's like hard to sort of like think, like have there's a lot of components to it, but I'm like, it's not that far out. So like, even if we can't do it in the next few months, I bet like in a year we could totally do it. And I expect that other people will do this too. But I'm like excited. I'm like it's going to be very interesting.
Yeah. I guess it's also more promising that like if I get an email from somebody purporting to be Jeffrey Ladish, like I can check the email address usually. But like I think there are just a lot of settings where I'm talking to someone via voice, and like it's because they clicked on a Google Meet link, or like they're like, I don't have my phone on me, so I'm calling from a friend's phone or something. Like it seems, I don't know, maybe the world just has to get better at like verifying who's calling you if I mean something in the voice.
I think that will be one of the things that will naturally have to happen, and like people will have to design defenses around this, because I think this is like it can be like one of the big shocks for people in terms of like, wait, the world is really different now, which is that I think people will like start to realize that they can't trust people calling them anymore. Like they just like don't know that they are like, because I think a lot of people will get scammed this way. And I think people will start to be like, shoot, if it's like someone, if it's a weird number and it calls me and it sounds like my mom, like it might not be my mom. And I think that's like very unsettling for people. It's just a weird thing to exist. And it's not necessarily the end of the world, but it is like a weird thing. And I think people are gonna be like, what?
Yeah.
What's happening?
I guess like maybe we just do more retreating to like now instead of phone calls, it's like, Facebook Messenger calls, or, like calls in some place where hopefully there is some identity verification.
Yeah. I think that seems like likely. Yeah.
Yeah. So my understanding is that you're like trying to, understand what current language models can do, and also like, having some interfacing with policymakers just to keep them up to date.
Yeah. I mean, the additional step here is like, okay, so let's say we like we've like run some good experiments on like what current systems can do.
Yeah.
And we've like, hopefully like both like the last generation and like the current generation, or like a few systems. So we have some sense of like how fast these capabilities are improving right now. And then I think we really want to be like also trying to communicate around like our best guess about where this is going. And so like both in like a specific sense, like, how much is this phishing stuff going to improve? Like we were just talking about like voice-based phishing and like models that can like, speak in other people's voices. But but also in terms of like what happens when AI systems that have these like, deception capabilities, have these hacking capabilities, become much more agentic and goal oriented and can like plan and can now use all of these like specific capabilities as part of like a larger plan. And many people have like already talked about these scenarios, right? Like, AI takeover scenarios, like, ways in which, this could fail and AI systems could seek power and gain power. But I think I want to sort of like be able to talk through those scenarios, in combination with like people being able to see the current AI capabilities to be like, well, these current AI systems can't do the like take power thing. But like what do we think has to be different? Like what additional capabilities do they need before they're able to do that? So that I think people can start thinking in that mindset and like start preparing for like, oh, well, how do we prevent the stuff we don't want to see? Like, I mean, how do we prevent AI systems from like gaining power in ways that we don't want them to? And so, so I think that's a very important component, because like, I mean, we could just like sort of go in and be like, here's our rough sense, but I think it's like going to be like more informative if we like combine that with like research that's like showing like what current systems can do.
Gotcha. So I guess the second component of kind of telling some story of like what things you need. I guess first of all, how's that? Where are you on that?
I think like right now it's like mostly at the level of like the kind of thing we're doing now, which is just like having conversations with people and like talking through it with them. We haven't like made any like big media artifacts or like written any like long position papers about it. We'll totally do some of that too. And like, I think try to make things that are pretty accessible to like a variety of audiences, maybe some videos, definitely some like blog posts and like white papers and such. But so far we're like in the planning stages.
Sure. So I'm wondering like how much of a response have you gotten from stuff that you've done so far?
The Bad Llama stuff was pretty interesting because like I knew like the whole premise of this was like, I'm like, here's a thing that I think most people in the AI research community understand. It's not very controversial. And I was like, and I think that most policymakers don't understand it. And like most people in the public don't understand it. Even though that was my hypothesis, I was still like surprised when in fact that was true. Like we'd go and show people this thing. And then they were like, wait, what? Like you can just like remove the guardrails? Like, what do you mean? They're like, that's scary. And like, it was really cheap. And I'm like, yeah, that's how it works. And people didn't know that. And I'm like, very reasonable for people not to know that. But I think, I don't know. I think I keep making this mistake, like not at an intellectual level, but at a visceral level, like at a system one level, where like, I think I assume people know the things I know, like a little bit. Or like if all my friends know it, then like surely other people know it. Like at some level, I know they don't, but like, yeah. So yeah, I mean, I think, we talked to people like, or like we had friends talk to people in Congress and sort of like show this work to them and like people in the Senate and people in the White House. And so like, there's definitely like a big mix, right? Like there's a lot of like very like technically savvy like congressional staffers that like totally get it and like, they already know, but then it's like they can then like take it and like go talk to other people. And so, yeah, I mean, like I think the most interesting stuff that happened with the Senate was like in the initial like Schumer forum, like Tristan Harris mentioned the work, like and like talked to Mark Zuckerberg about it, and Mark Zuckerberg was like sort of made the point that like, well, you can get this stuff off the internet right now, and I'm like, yep, that's true, but like, can we talk about future systems? Like like this is like we really got to figure out like what is the plan for like where your red lines should be, and so I don't know, I think it was like a little bit. I think like people are like really anchored on the current capabilities, and like the thing we really need to figure out is like, how do we decide like where the limits should be, and like how do we decide like how far we want to take this stuff before like the government says like you need to be doing a different thing. And that's I'm like getting a little bit of a rabbit hole, but I feel like that's like the whole question I have right now with like AI, like governance of AI systems. Where like currently like the governance we have is like, well, we'll like keep an eye on it. And like that's, I mean, like you can't do crimes. Like we'll keep an eye on it and you can't do crimes. And I'm like, man, it sure seems like we should like actually be more intentional around saying like, well, we are moving towards systems that are going to become generally capable and like probably super intelligent. That seems like that presents a huge amount of risk. Like at what point should we say like, you have to do things differently? And like it's not optional. Like you are required by the government to do things differently. And I think that's just like the thing we need to figure out as a society, like as a world, really. And I don't know, I just want to say it because that feels like the important, obvious thing to say. And I think it's like easy to get lost in details of like evaluations and like, oh, but like, what are like the risks of like misuse versus agency and all of these things? And I'm like, man, at the end of the day, like, I feel like we got to figure out like, how should we make AGI and like, what should people be allowed to do and not do, and like in what ways? Yeah.
So like, yeah, I mean, this question of like, how do we, at what point do things need to be different? Like, yeah, how do you think we answer that? Like, it seems like stuff like demos is sort of on the like step of just like observe, figure out what's happening.
Yeah.
Is that roughly right?
Yeah, I think so.
Yeah. I don't know. Do you have thoughts about like where things need to go from there?
Yeah. I mean, I think like we need to try to like forecast like what kinds of capabilities we might have like along what relevant timescales. And I think this is very difficult to do. And like we'll have like pretty large uncertainty. But I think like, you know, if I were the government, I would be like, well, how far off are these like very general purpose capabilities? How far off are these like domain specific but like very dangerous capabilities? How much uncertainty do we have, and like what mitigations do we have, and then like try to act on that basis. And I'm like, if the government believed what I believed, I think they would be like, all frontier developers like need to be like operating in very secure environments and need to be like very closely reporting what they're doing, and need to be like operating as if they were like more like a, you know, nuclear weapons project than they are like a you know, tech company. And that's because I think that there's like a substantial possibility that like we're not that far from like AGI. And like we don't know. And like from my like epistemic state, I'm like, yeah, maybe it's 10 years. I'm like, or maybe it's 2. And if you have that much uncertainty and you think there's like a 10% chance that it's 2 years, I think that like more than justifies taking pretty drastic actions to like not accidentally stumble into systems that you like won't be able to control. And then like, you know, on the domain specific stuff, I think our society is like potentially pretty robust to a lot of things. I think on the like bio side, there's potentially some scary things that are not there yet, but I think we should definitely be like monitoring for those and like trying to mitigate those like however we can. But I do think it's more like of the agentic capabilities to like scientific R&D, the sort of more like general intelligence things that are like, yeah, I think there's like definitely points of no return. If we like go beyond those things, I think it's like unlikely we'll be able to like stay in control of the systems. And yeah, I'm like, I don't know. I think like, you know, like I think the first thing you need to do is like be able to like actually have a like off switch or like an emergency brake switch to say like, whoa, if we like if we like cross these red lines, like, I mean, like there's definitely like many like red lines I could say that are like, if you have gotten to this point, you're like, you've clearly gone too far. Like if you suddenly like get to the point where you can like 100% just like turn your AI systems into researchers and have them like build the next generation of a system that is like more than 2x better, and it took no humans at all. I'm like, yes, you have gone too far. You now have an extremely dangerous thing that could potentially improve extremely quickly. We should definitely like, before we get there, like stop, make sure we can secure our systems, make sure that we have a plan for like how this goes well. And then I'm like, oh, I don't know where like the right place to put the red lines are.
Yeah.
But I'm like, I don't know. I want like Paul Cristiano and like, you know, I want to sort of take like the best people we have and like put them in a room and like have them try to hash out what the red lines are, and then like make hopefully very legible arguments about where those red lines should be, and then like have that conversation. And I'm like, yeah, you know, there's going to be a bunch of people that disagree. I'm like, sure, throw Jan LeCun in the room too. Like that will suck. I don't like him, but like he's a very respected, you know, researcher. So I'm like, I do think it shouldn't just be like the people I like. I'm like, but I think that like a lot of the AI research community could get together, and like the government could get together and like choose a bunch of people and like end up with the not totally insane assortment of people to try to figure this out. And I'm like, that seems like a thing we should do. Like it just seems like the common sense thing to do, which is just like take the best experts you have and try to help them, try to get them to help you figure out like at what point you should like do things very differently. And maybe we're already at that point. I think we're already at that point. If I was on that panel or like in that room, that's what I would argue for. But you know, people can reasonably disagree about this, but that's the conversation I really want to be happening. And I feel like we're like inching there, and we're like talking about evaluations and like responsible scaling policies and all this stuff. And I'm like, yeah, it's good. It's like in the right direction. But I'm like, man, I think we gotta like have these red lines like much more clear and like be really figuring them out like now, like yesterday.
Yeah. I mean, I guess a bunch of the difficulty is just defining like what are we like concretely, what's the actual stuff we can observe in the world that's like the relevant types of progress or the relevant like capabilities to be kind of worried about. Like I think I guess like a cool thing about the like AI safety levels, I'm embarrassed to say that I haven't read them super carefully, but like stuff like evaluations, AI safety levels, it seems nice to just be able to have a thing of like, hey, here's a metric, and if it gets above 7, that's pretty scary.
Yeah,
you know?
Yeah, I do like this. I quite like this. Yeah, and I think that like the people working on those have done a great job taking something that was like not at all legible and making it much more legible. Yeah. And I mean, I think some work that I really would like to see done is like on the understanding based evaluations, where we don't just have evaluations around how capable these systems are. We also have evaluations on how well do we actually understand what these systems are doing and why they're doing it. Which is like, measuring sort of our ability to like do mechanistic interpretability on some of these systems. So like Evan Hubinger at Anthropic has like proposed this as like an important direction. But as far as I know, we have like not yet developed. So, I mean, when I talk to the interpretability people, what they say is like our interpretability tools are not yet good enough for us to even be able to specify what it would mean to like really understand a system.
Yeah.
And I believe that that's true, but I'm also like, I talk to the same researchers and I'm like, well, do we understand the systems? And they're like, no, definitely not. And I'm like, okay, but so you seem confident that we don't understand these systems, and like you have some basis for your confidence. Can you give me like a really bad metric for how like like a very preliminary metric to be like, well, if we can't answer these questions, we definitely don't understand them. Like just because we can't answer these questions doesn't mean we super understand them well. But like this thing is like a bit far off and we can't do it yet. I would like that, because I think then we could at least like have any understanding based evaluation, and then hopefully we can develop much better ones. But like I think as like the capabilities increase and the danger increases, I really want us to be able to like measure how much progress we're making on like understanding what these systems are and what they do and why they do them, because that is like the main way I see us like avoiding the failure modes of like, well, the system like behaved well, but like sorry, it was deceptively misaligned and it was like plotting. But like you didn't have any, like you weren't testing for like whether you understood what was going on. You only tested for like, did the behavior look nice? But I think there's a lot of very sound arguments for like why systems might look nice, but like in fact be plotting.
Yeah, I'm wondering what you think about like so I think of like Redwood researchers work on causal scrubbing, where like essentially what they're trying to answer this question of like, okay, you say that like this part of this network is responsible for this task. Can we check if that's right?
Yeah.
And they're roughly trying to say like, okay, we're gonna like compare like how well the network does on that task to like if we like basically delete that part of the network, how well does it do then? I'm wondering like, one might have thought that would be just what you wanted in terms of understanding based evaluations. What's the gap between that and what's sufficient?
I don't know. I think I don't understand the causal scrubbing work well enough to know. I mean, that seems very good like to do.
I mean, I guess one difficulty is it's just like this part of the network is responsible for performance on this task. And it's a bit there's still a question of like, well, what's it doing? What like why is it responsible for that? Like,
yeah, I mean, I think there's probably many stories you could tell where you could have a tool like that like appeared to be working correctly, but then like the model was still scheming. I mean, it does seem great to like have any tool at all that can like detect, that can like give you additional checks on this. But I mean, I think this is true for a lot of interpretability tools where it's like, it'd be very good if they got to the point where they could start to detect bad behavior. And like, I expect you'll be able to do this long before you have like a fully mechanistic, like explanation for all of what's happening. And so this like gives you the ability to like detect potential threats without being like a super robust guarantee that you like that there are no threats.
Yeah.
And I'm like, yeah, better than nothing. Let's just like not confuse the two. Like let's like note that like we will catch more than we would have otherwise, and so but we like don't know like how many we'll catch per se.
Yeah, I guess it's also about like validating an explanation rather than like finding threats. Like,
yeah, I see. Yeah. That makes sense.
There's also, it also has this limitation of just being about bits of the network, where it's like you might have hoped that you could understand and neural network behavior in terms of like its training dynamics or something. Like causal scrubbing doesn't really touch that. I guess like the closest thing to this that I don't know, I'm probably don't have an exhaustive view of this literature, but like a previous guest on the podcast, Stephen Casper, has some stuff basically just like trying to get benchmarks for interpretability and trying to say like, can we like understand XYZ behavior? Can you use your understanding to do this task or that task?
Yeah. Love to see it. That's great.
Yeah. And I don't know, basically the answer is like interpretability is not doing so hot yet.
Yeah, that makes sense.
Unfortunately. So I guess we're about at the end of the discussion. Before we close up, I'm wondering, is there anything you wish that I'd asked that I haven't?
Yeah, that's a good question. Let me think about that a bit. I don't know what the question is exactly, but there's an interesting thing about our research at Palisade, which is like some of it is just like trying to like understand, because we don't know the current capabilities of systems, and it's like quite interesting, like from an evals frame, because like evaluations I think are often framed as like we're trying to understand how capable this like model is. But like that's kind of true, but like what you're testing is like how capable is this model combined with this programmatic scaffolding, which can be quite complex, and like, or how capable is this model combined with this programmatic scaffolding and other models. And like we don't necessarily know how far, like how much scaffolding will like influence this, but like at least a fairly large degree. So I think like, so I mean, a lot of this research with evals, with like demonstrations, this is like a question of like, what is it for? Like some of it's for like just trying to understand stuff, like just like how good are models, how good is our models plus scaffolding. But another part of it is like trying to like make AI capabilities more legible. And I think this is like a very important part of like the research like process, and like sort of like for organizations that are trying to like do research and communication, because I see like our best shot at like a good AI development path is one where it's a lot more legible, like what like the risks are, like what potential mitigations and solutions are, and like sort of like still how far we need to go. There's just like a lot more about like AI development that I want to be more legible, in part because I think that I really believe that like because of how fast this is going and because of how like multipolar it is and like how many like different actors there are, we like really need to be able to coordinate around it. We need to coordinate around like, well, like how, like when do we want to make AGI? Like when do we want to make super intelligent systems? Like how risk tolerant are we, like as the United States or like or as the world, are we? And like right now, I don't think that most people like have grappled with these questions, in part because they don't really know that we are facing these things. Like they don't know that like there's a bunch of companies that have in their 5-year plan like build AGI, like be able to replace most human workers. But I think that is the case. And so I'm like, well, it seems like now is a very important time to have conversations and like actually like put in place political processes for trying to like solve some of these governance and coordination questions. And I think in order to do that, we're going to have to like explain a lot of these things to a much wider audience, and not just have this be a conversation among AI researchers, but like a conversation among AI researchers and policy experts and like policy leaders and like a lot of random constituents and a lot of like people who are in media and a lot of people who are like working on farms. I'm like, yeah, I think that like a lot more people need to understand these things so that they can like be able to advocate for themselves for things that like really affect them. And this is very difficult, right? I'm like, I think it's very hard to like in some sense it's like not difficult because I think some of the basic risks are like pretty intuitive. But like what's difficult is that people have so many different takes on these risks, and like there's so many different ways to like make different points, that you have like Jan LeCun over here being like, oh, you guys are like totally wrong about this existential risk stuff. And you have like Hinton and Bengio over here being like, no, actually, I think these risks are super severe and important, and we have to take them very seriously. And, you know, people might have somewhat good intuitions around these, but also now you have like a lot of sophisticated arguments you have to try to evaluate and figure out. And so I'm like, I don't know how to solve this, but I'm like, I do want much more legible things that more people can follow so that they can like weigh in on the things that I think do affect them a lot.
Gotcha. Well, so just finally, before we end, if people are interested in following your research, how should they do that?
Yeah, so they can follow, we'll be posting stuff on our website, palisaderesearch.org.
Okay.
You can follow me on Twitter at Jeff Ladish. I go by Jeffrey, but when I made my Twitter account, I went by Jeff. And yeah, we'll probably be publishing in other places too. But those are probably the easiest places to follow.
All right. Well, thanks for coming on the podcast.
Yeah, thanks for having me.
This episode is edited by Jack Garrett, and Amber Dornace helped with transcription. The opening and closing themes are also by Jack Garrett. Far Labs provided the filming location. Financial support for this episode was provided by the Long-Term Future Fund and Lightspeed Grants, along with patrons such as Alexei Malafeyev. To read a transcript of this episode, or to learn how to support the podcast yourself, you can visit axrp.net. Finally, if you have any feedback about this podcast, you can email me at feedback@axrp.net.